Hello there and welcome to Just About Earth, where curiosity takes a quieter route and the world grows a little softer around the edges. Tonight we're settling into a question that people have whispered, argued about, and wondered over for longer than any of us have been alive. It's an idea that sits right at the border between science and imagination, not in a dramatic way, but in a steady, thoughtful way that encourages the mind to slow down. This time we're exploring the puzzle of how many civilizations may have existed long before our own, hidden beneath layers of soil, water, and everything else the planet has shifted over the ages. It's a question that doesn't rush you and doesn't demand certainty. It simply invites you to wander through possibilities, to consider what might lie beneath the familiar ground we walk on each day, and to follow the thread of curiosity wherever it leads. Before we drift into that landscape of ideas, I'd love to know where you're listening from tonight, and what time it is for you right now, in your space and your moment, wherever you happen to be. Maybe you're winding down after a long day, maybe you're just settling into bed, or maybe you're somewhere between alert and sleepy, letting your thoughts relax a little. If any part of this brings you comfort or eases you into rest, it would mean a great deal if you gave the video a like or subscribed so this calm corner can reach others who might enjoy it as well, but only if it feels right for you. The priority here is simply that you settle in and let yourself ease into this gentle line of thought. The idea of civilizations that existed before ours sounds straightforward at first. We tend to picture ancient ruins, old temples, abandoned structures, and traces of past people left behind on purpose or by accident. But when we look deeper, the question becomes much larger than any one time period or any one culture. Earth has existed for over 4.5 billion years, and humans, the kind who build communities and tools and structures and stories, have been around for only a small portion of that. When you place those facts side by side, it becomes easier to understand why this question emerges so often. If the planet has had such a vast amount of time to work with, could other civilizations have lived and disappeared long before the ones we know? Could whole societies have risen and vanished without leaving recognizable traces behind? This isn't about secret ancient technology or dramatic interpretations. It's about looking at the scale of Earth's history and noticing how little of it has been filled with written records or even permanent structures compared to the total amount of time available. It's about acknowledging how quickly things disappear when nature has full control over them. Wood rots, metal corrodes, stone breaks down, soil shifts, water spreads across coastlines, ice sheets move and melt, mountains rise and crumble. In just a few thousand years, landscapes can transform so thoroughly that even the traces of cities we know existed become nearly impossible to find. And if that's true for things we can verify, it opens the door to wondering about things we can't yet verify, not in a dramatic way, but in a patient, steady manner that simply asks, what else might have been here if we had the ability to look deeper? When people talk about civilizations that might have existed before ours, the mind tends to jump to something grand, like global networks or advanced technologies. But the possibilities don't have to be so large. Civilizations come in many forms. They can be small, scattered communities with shared customs. They can be groups with organized structures and traditions. They can be societies without writing, but with strong patterns of cooperation and knowledge. They can build homes, tools, and art that don't last long enough to become fossils. And they can thrive for thousands of years before nature quietly erases their traces. If you've ever walked through a forest and come across the remains of an old cabin or a stone foundation hidden under moss and vines, you know how quickly the planet reclaims what humans build. That's over just a few decades. Scale that up to centuries, then thousands of years, then tens of thousands. Then try to imagine what remains from tens of millions of years ago. Even the hardest materials change over time. Entire mountains disappear. Coastlines shift. Rivers carve new paths. Volcanoes create new land, while earthquakes reshape older terrain. If you try to picture where our cities will be in 10,000 years, the image becomes hazy. If you stretch that out to 100,000 years, the prediction becomes even harder. And when you stretch the timeline deep into the millions, the entire context changes. That's the environment in which this question sits. One of the interesting things about this topic is that scientists ask it too, though through careful phrasing and rigorous study. Not because there is evidence of lost civilizations on Earth, but because the sheer age of the planet forces us to consider how incomplete our archaeological record must be. We have fossils of animals from hundreds of millions of years ago because bones can fossilize under the right conditions. But the things humans build are not bones. They are fragile. They are temporary. They break, dissolve, rust, collapse, and sink. Even large modern structures would not last long enough to become fossils. Most would be gone within a few thousand years, leaving faint chemical traces rather than recognizable shapes. If we imagine a timeline stretching back through the ages, we quickly see how narrow our window of known history is. Written records go back around 5,000 years in a few parts of the world. Complex agriculture emerged tens of thousands of years before that. Homo sapiens have existed for roughly 300,000 years. Earlier human species existed for millions of years, and that's still a tiny fraction of the planet's total age. It means that even if humanity has been here for a long time, we've been here for only a moment compared to the entire stretch of Earth's history. And during all those eons, the planet was not empty. It was full of life, climate changes, shifting environments, and events that shaped the world we see today. Whether any of that life developed into civilizations like ours is something science cannot answer yet. But the question remains open, because the timescale allows for possibilities that aren't easy to dismiss. The comforting thing about this line of exploration is that it doesn't require certainty. It's a slow walk through ideas rather than a race toward conclusions. When we ask how many civilizations may have existed before ours, we're not assuming they must have been similar to us. We're not assuming they had technology or writing or cities. We're simply acknowledging that the Earth is old enough and dynamic enough that many chapters of its story are lost to changes in climate, geology, and time. And in those missing chapters, it's reasonable to wonder what kinds of societies may have lived their entire existence before the world became what we know now. Coastlines are a good example. 10,000 years ago, sea levels were much lower due to the amount of water locked in ice sheets. Entire regions that are now underwater were once dry land. Many human settlements from that time, or earlier, are now beneath the ocean. Not because anything dramatic happened to them, but because coastlines shift naturally. If small coastal societies existed long before recorded history, their remains may be deep underwater today, buried beneath sediments. And if something existed even further back in time, the evidence would be even harder to find. Ocean floors recycle themselves. Entire stretches of seabed disappear into the earth through tectonic processes. Anything built on those surfaces would be drawn back down into the mantle over millions of years. The more closely we observe Earth's natural cycles, the more we realise how fragile the human footprint is. And that fragility is what makes the question so interesting. It doesn't insist that civilizations existed long before ours. It simply recognises that if they did, finding evidence would be extraordinarily difficult. Not impossible, but difficult in a way that requires new tools, deeper exploration, and an understanding of how thoroughly time reshapes everything. It's like trying to read a book where most of the pages have been weathered away, and only a few remain. You can see part of the story. But you also know there's far more you're not seeing. This topic also encourages us to consider what civilization truly means. We often picture large cities, monuments, and complex architecture, but those are only one form of civilization. Many societies throughout human history left minimal physical traces. Some cultures avoided stone entirely. Some preserved knowledge through oral traditions rather than writing. Some built temporary structures that were meant to be rebuilt, not left behind. And some civilizations were relatively small, thriving in stability without needing grand structures. If we only look for stone monuments or durable artifacts, we overlook countless ways that people organized their lives, built their communities and shaped their world. When researchers study ancient societies, they often rely on tiny pieces of evidence: a fragment of pottery, a tool shaped from bone, seeds preserved in a dry cave, ash from a hearth, scattered footprints in hardened mud. These are the survival of the rare, the chance discoveries, the things that manage to endure under ideal conditions. The vast majority of human life leaves nothing behind. Nature is thorough in its cleanup, and if that's the case for societies from the last few tens of thousands of years, imagine what applies to timescales in the millions. The Earth is not static. It shifts constantly. If you look at a map of the world from various points in geological history, continents drift like slow-moving puzzle pieces. Forests become deserts, deserts become grasslands, grasslands become wetlands. The settings change so thoroughly that it becomes difficult to imagine where anything used to be. That's the backdrop for this exploration. Not a dramatic narrative, but a steady, thoughtful recognition of scale. When we ask how many civilizations came before us, we're not challenging established history. We're simply asking whether history as we know it represents the full story, or just the parts we can observe. And because the planet has so much hidden beneath its surface, and because time is so long compared to the lifespan of any single species, it becomes natural to wonder about possibilities that lie beyond the reach of our current tools. As we continue through this quiet conversation, we'll move from the question itself into the ways Earth preserves and erases its past. The goal isn't to arrive at a final answer. The goal is to follow the path of curiosity in a gentle, steady way that lets the mind relax as it considers the vast timeline beneath our feet. When we begin thinking about what the Earth keeps and what it quietly removes over time, the scale of the problem becomes clearer. Most of what humans create is temporary, even if it feels permanent while we're living with it. The objects and structures that seem solid and dependable to us are, in the eyes of the planet, no more durable than a footprint on a beach. It takes only a few cycles of weather, erosion, or shifting ground before something that once held meaning becomes almost impossible to recognize. And for anything that's been gone long enough, even the faintest outline can vanish completely. That's why the idea of earlier civilizations becomes tangled not with certainty, but with the sheer fragility of memory, both biological and geological. The world doesn't protect everything that passes through it. It cannot. There's simply too much time involved. If you imagine a simple wooden structure left exposed in a forest, you can picture how quickly it would break down. A few years of rain, insects, plant growth and wind would weaken it. A few decades would take it apart almost completely. After a century, only the most protected pieces might survive, buried under leaves or soil. Give it a few centuries more and even those traces would blend into the surroundings. Soil layers form, tree roots move through the space, microbes break down fibres. What remains becomes indistinguishable from the environment around it. This is the reality for things left in open air. But even structures built from stone, which we tend to think of as lasting forever, do not survive indefinitely. Stone cracks with temperature changes, softens underwater, wears down under wind, crumbles when plants push through it. The harder the material, the longer the process takes, but the outcome is the same over long enough periods of time. Archaeologists understand this deeply because they see how much effort is required to interpret even the most recent layers of human history. Entire cultures have left behind only fragments that need careful reconstruction. Sometimes a whole population lived in an area for thousands of years, yet all that remains now is a handful of tools and a few hearths. Even in cases where people worked with metals or carved stone, the survival of those items depends heavily on the environment. Dry climates preserve things. Wet climates destroy them. Acidic soil breaks down bone and organic materials. Ocean water corrodes metal beyond recognition. When viewed through this lens, it becomes obvious that the Earth is not a reliable librarian. It does not save everything in neat categories. It mixes, erases, buries, dissolves, and rearranges. This doesn't just happen in forests or open fields. Cities themselves, even large ones, can disappear shockingly fast once they're abandoned. Consider places that have been deserted for just a few decades. Buildings collapse under plant roots, roads crack, bridges weaken, roofs fall in, vines cover surfaces. Wildlife returns, water floods lower areas. Without constant repair, most human-made environments lose their shape, and that's before earthquakes, landslides, floods, or volcanic activity add their effects. If a city remains untouched for long enough, it eventually blends into the landscape so completely that only detailed excavation could reveal that anything was there. Now expand that idea into the timescales geologists work with. 100 years is barely noticeable. 1,000 years is a single layer of soil. 10,000 years is enough time for climate shifts. 50,000 years can transform coastlines. 100,000 years might erase entire landforms. 1,000,000 years reshuffles everything. In 10 million years, continents drift significantly. Mountains rise and fall, rivers carve deep valleys, seas open and close, and across hundreds of millions of years, the surface of the Earth can change so profoundly that no physical trace of a former landscape remains. This is the reality into which we place the question of earlier civilizations. Even fossils, which we often view as reliable evidence of the past, rarely form. Most organisms that have ever lived left no fossils whatsoever. Fossilization requires extremely specific conditions: rapid burial, mineral-rich water, very low oxygen, and a long period of stability without disturbance. Without those conditions, organisms decay completely, and humans, with their temporary shelters and portable tools, are not likely to create fossil-friendly environments. A civilization would need to leave behind unusual concentrations of materials in the right geological settings for anything to survive long enough to be found millions of years later. And even then, the remains might look more like mineral deposits or chemical signatures than recognizable artifacts. The concept of memory works in a similar way, though on a different scale. Human minds are excellent at preserving stories, ideas, and impressions, but those memories are fragile as well. They can be reshaped, forgotten, merged, or lost. Oral traditions can keep knowledge alive for long periods, but only if enough people repeat it. Once a community disappears or disperses, its memories disperse with it. Written records help stabilize information, but they require stable materials and preservation conditions. Many ancient texts have already been lost to fire, moisture, insects, or simple decay. Others survive only as copies of copies, with the original versions long gone. When you look at our earliest written histories, you see clear gaps. Entire cultures appear suddenly with little explanation of how they developed. Others vanish with barely a trace, and those examples come from relatively recent times. If we consider how quickly human memory fades without stable preservation, we can begin to appreciate how little of earlier eras might remain. A society without writing leaves behind knowledge only as long as its people remain connected. Once they fragment, their stories evolve into myths, then legends, then something harder to link to real events. Over long periods, stories blend with new interpretations. They not only change in detail, but shift in meaning. And eventually, even the origin of the story becomes uncertain. That is why so many ancient myths from around the world sound similar yet differ in crucial ways. They carry echoes of earlier experiences, but not the complete record. This fragility of memory extends to the physical landscape as well. A region heavily populated in one era might be abandoned in another, then repopulated again centuries later, with each wave erasing part of what the previous one left behind. Farming alters soil layers. Construction buries older levels. Floods wash away evidence. Fires clear entire settlements. And when people move into a space already shaped by earlier inhabitants, they often reuse materials, repurpose foundations, and reshape the land to fit their own needs. Over multiple cycles, the distinction between one era and another becomes difficult to see unless specialists perform detailed, careful excavation. Much of what we know about ancient societies comes from chance. A volcanic eruption buried a city before it could decay. A desert environment provided natural protection. A cave sealed off a site. A sediment layer covered a village at just the right moment. Without these unusual events, most small communities would leave almost nothing behind. That reality becomes more significant when we consider that many past societies may have been small, mobile, or built with materials that do not endure. Structures made of wood, clay, fibres, or earth degrade quickly. Tools made from organic materials disappear. Even pottery, which is more durable, breaks into fragments that can be scattered or eroded. The deeper into the past we go, the more pronounced this problem becomes. Tens of thousands of years ago, humans lived in ways that were far less likely to leave lasting marks. They adapted to their environments using resources that decayed quickly. They moved seasonally in many regions. Their tools were effective but rarely durable on geological timescales. Their shelters were often temporary. Their footprints vanished with the next rainstorm. And some lived in regions where erosion is constant, meaning even the small traces they left would not survive long enough for discovery. If we imagine civilizations that came before any known ones, we must consider the possibility that they existed in ways that didn't lend themselves to long-term preservation. Their forms of organisation could have been entirely different. They might have used materials that disappeared quickly. They could have arranged their communities in patterns that left minimal disturbance to the landscape. They might have lived along coastlines that are now underwater. They could have spread across regions where thick vegetation or active geology hides their traces. And if they lived tens of thousands or millions of years ago, almost nothing they made would remain intact. Scientists sometimes point out that if a civilization as advanced as ours had existed millions of years ago, we would expect to find chemical traces or unusual deposits. But even that isn't straightforward. Natural processes create many patterns that resemble industrial remnants. Metals concentrate through geological processes. Minerals form in unusual shapes. Shifts in climate produce unexpected chemical layers. The Earth has countless ways of creating structures that can be mistaken for artificial patterns. And even if something were artificial, distinguishing it from natural formations would be difficult unless it was clearly manufactured. But anything clearly manufactured would need to survive not just years, but millions of years of pressure, heat, erosion, and chemical changes. The more we consider the fragility of memory and material evidence, the more we see how incomplete the story of human existence must be. We are piecing together a vast timeline from fragments that survived by chance, and the timeline we're familiar with stretches back only a fraction of the planet's history. Before that, we rely on fossils, chemical signatures, and geological layers to understand what happened. These tools are powerful but not perfect. They tell us much about climate, ecosystems, and major events, but they cannot capture the fine details of any society that didn't leave durable marks. Our modern world gives us an illusion of permanence because we see reinforced structures, large cities, and durable materials. But these are temporary on geological scales. If our civilization disappeared tomorrow, nature would reclaim our cities in a matter of centuries. In a few thousand years, most surfaces would crumble. In a few tens of thousands, only deep foundations might remain. And in a million years, even those might be distorted beyond recognition. The Earth rarely offers long-term stability. It is always shifting, weathering, eroding, melting, freezing, and reshaping. No matter how large or impressive a structure is, time eventually reduces it to raw materials. When we look at our own presence this way, the idea of earlier civilizations becomes less about speculation and more about acknowledging how much could be erased simply by the passage of time. It doesn't require imagining advanced technology or grand networks. It only requires understanding how fragile traces are. The planet has cycled through environments so different from today's that certain eras would be unrecognizable. Shorelines have moved thousands of kilometers. Climate bands have shifted, ice sheets have grown and receded, mountain ranges have risen and disappeared. Every one of those changes alters the physical record in ways that are difficult to reconstruct. When we look back at the earliest periods of human life, we're often struck by how much of the story is missing. Everything before writing appears quieter, not because people lacked activity or thought, but because their voices did not leave marks that survive in the way ink on durable surfaces does. The world before written records stretches across almost the entire existence of our species, and during that time people lived full lives, shaped communities, built tools, created traditions, and learned to navigate landscapes that were constantly changing. Yet nearly all of it unfolded without leaving a clear record we can read. The result is a long silence, not in the sense of inactivity, but in the sense that the evidence required to describe it in detail no longer exists. Writing emerged surprisingly late when compared to the age of humanity. Our species has been around for roughly 300,000 years, yet the oldest known writing is only about 5,000 years old. That means most of human existence took place in a period without written accounts. Even when people began carving symbols or using markings to track quantities, those early forms were limited in scope. They recorded trade, storage, or simple labels rather than personal experiences or histories of entire communities. Everything else had to be carried through speech, memory, and communal learning. Those methods work well while populations remain stable and connected, but if groups move, split, face disasters, or slowly decline, the survival of their knowledge becomes uncertain. Before writing, information had to be preserved through teaching. Knowledge moved from person to person in the form of stories, instructions, and shared practices. A skilled builder taught someone else how to shape a tool. A healer taught another how to prepare certain plants. A parent told a child how to navigate a region, avoid dangers, and understand seasonal changes. These forms of memory were powerful, but they depended entirely on continuous chains of transmission. If a community dwindled, or if a group encountered an unexpected challenge that disrupted normal patterns, the knowledge they held could vanish quickly. A generation or two of interruption was often enough for techniques, meanings, and histories to slip away. When we look at the archaeological record for this period, we see only fragments. Stone tools appear in layers of sediment scattered across regions that once supported early populations. Fire pits show where people cooked or gathered. Bones indicate what they hunted. Occasionally, cave paintings provide hints of what they valued or observed. But these are isolated pieces. They do not assemble into full narratives by themselves. They show that humans were creative and adaptive, but they do not reveal the full range of experiences that shaped those lives. Entire cultures could rise, interact, stabilize, and disappear without leaving more than a handful of durable materials. Human activity during this long, pre-literate era was not limited to isolated groups. Populations moved across continents. They figured out how to survive in deserts, forests, coasts, grasslands, and cold environments. They discovered how to use fire strategically, how to work with stone, how to create adhesives, how to build shelters suited to specific climates, and how to form groups strong enough to raise families and survive environmental changes. These are accomplishments worthy of long histories, yet most of their stories remain silent simply because they were not written down and because the physical world removed much of what they left behind. There's an important detail to consider when thinking about this silence. Humans lived through dramatic climate shifts long before writing existed. Entire glacial periods came and went. Sea levels rose and fell by hundreds of meters. Landscapes transformed into entirely new environments. As the climate changed, human groups adapted by migrating, altering their techniques, or changing their patterns of life. Many of the places humans occupied during these times are now submerged, eroded, or covered by thick layers of sediment. Sites on ancient shorelines lie far below modern oceans. Sites in valleys that once supported large populations have been buried under river deposits. Volcanic eruptions sealed some regions and erased others. In many cases, whatever existed in those places is now inaccessible. Without advanced tools we are only beginning to develop. If a community lived on a coastline during a period when the sea level was significantly lower than today, their structures, tools and materials would now be underwater. This doesn't require imagining anything advanced. Even small settlements leave traces when conditions are ideal. But underwater archaeology is difficult. Currents move sediment, organisms consume organic materials, chemical reactions corrode metal, sand covers and uncovers surfaces repeatedly. If a site survives intact, it is a rare exception rather than the norm. Most evidence is scattered or dissolved long before researchers can find it. Even on land, the survival of pre-literate traces is uncommon. Over thousands of years, soil layers form through the slow breakdown of organic matter. Buried items move downward through this process. If an area experiences heavy rainfall, flooding, landslides or erosion, the layers mix. Items from different eras can blend. Items that once sat on the surface can shift several meters down. Items close to the surface can disappear entirely. Archaeologists often rely on very stable environments such as caves, dry deserts, or volcanic ash layers to find well-preserved materials. Outside those rare conditions, the record becomes thin and difficult to interpret. Another factor that contributes to the silence before writing is the nature of early human tools and structures. Much of what people used was made from materials that decay rapidly. Wood, fibres, plant materials, clay without firing, and animal skins all decompose under normal environmental conditions. Tools made from bone or antler last longer, but they too can break down in certain soils. Only stone tools commonly survive across tens of thousands of years. Because of this, the periods before writing are often described through the lens of stone implements. But focusing on stone alone creates an incomplete picture. Stone tools represent only a fraction of what people created. They do not show clothing, baskets, containers, shelters, fishing equipment, musical items, or many kinds of art. The diversity of human life during this time was far greater than the surviving record suggests. Groups in warm regions likely crafted complex items from plant fibres or lightweight wood. Groups in colder areas made clothing and shelters suited to harsh environments. Communities near rivers and lakes developed techniques for building boats, traps, and storage systems that relied heavily on materials that do not survive. Social structures, cooperation strategies, healing knowledge, and beliefs all existed, but left no physical mark durable enough to remain. Another layer of complexity comes from the way populations moved. Humans have always been mobile, especially when environments shifted. Mobility protects groups from short-term challenges, but makes long-term physical records less likely. A community that relocates every season or every few years doesn't build large permanent structures. Instead, they learn to use the landscape efficiently without leaving deep imprints. This lifestyle is practical and sustainable, but nearly invisible in archaeological terms. Over a span of several thousand years, a region could support many generations of people who left almost nothing behind that we can find today. As we explore longer timescales, we encounter more uncertainty. Before Homo sapiens, earlier human species lived on the planet for long periods. Some built tools, some controlled fire, some formed social groups that lasted for thousands or millions of years. But the traces they left are sparse. Many regions where they lived have changed completely. Ancient riverbeds shifted, lakes dried up, forests replaced grasslands, ice sheets advanced and retreated. The landscapes that shaped their lives no longer exist, and without writing, their experiences left no direct records. When we think about the possibility of civilizations before known history, we must include the idea that societies do not always follow the same developmental path. A community could reach a stable, organised form without requiring monumental structures, large-scale agriculture, or permanent settlements. They could develop systems of knowledge suited to their environment without building durable objects. They might have created complex social patterns that left almost no archaeological signature. If they thrived in regions that have since been deeply altered, the likelihood of discovering their traces becomes extremely low. The long silence before writing emerged is not a sign of inactivity or emptiness. It reflects the difficulty of preserving information across extended periods. Even after writing began, many records were lost due to environmental factors or human actions. Fires destroyed libraries. Invasions disrupted centres of knowledge. Storage materials decayed. Even texts carved into stone eroded. If writing itself is fragile over millennia, the absence of writing makes earlier eras even more challenging to reconstruct. Some researchers use the concept of the archaeological visibility threshold to describe the amount of activity required for a society to leave detectable traces. Below a certain threshold, even continuous human presence may not create enough durable material to survive. A group could maintain a rich cultural life for thousands of years without leaving behind enough evidence to appear in the archaeological record. When writing eventually arrived, it captured only a small portion of the world's cultural diversity. Many societies continued living without written systems. Their histories remained oral, their knowledge paths shifted with each generation, and when they eventually transitioned or merged with other groups, their unique identities faded into larger patterns that now appear simpler than they once were. This long period before writing also shaped the myths and stories that appear in later cultures. Many traditions include memories of ancient times, migrations, climatic events, or significant environmental shifts. These stories often blend memory with interpretation. By the time they are written down, they reflect centuries of retelling. They offer glimpses of older experiences but not detailed accounts. Some may preserve real events such as floods, droughts, volcanic eruptions, or population movements, while others represent symbolic interpretations. Without written records from the time of origin, it becomes difficult to separate memory from storytelling. This makes the earliest eras feel distant even when they were filled with activity. Understanding the silence before writing allows us to see the vast amount of human life that has been lost to time. It is not just the silence of unrecorded history, it is the silence of erased landscapes, submerged coastlines, dispersed communities, shifting climates, and fragile materials. When we acknowledge how easily evidence disappears, we begin to appreciate how limited our view of the past truly is. We know only the slivers preserved by chance, and those slivers point toward much larger patterns that once existed but are now beyond our reach. When we look at the map of the world as it exists today, it's easy to imagine that coastlines, islands, and continents have always been arranged the way we see them now. Most of our daily experience reinforces that sense of stability. A beach you visited years ago looks roughly the same. A harbour remains familiar to you each time you return. But if you shift the perspective to geological time, the picture becomes completely different. Coastlines move, sometimes gradually over thousands of years, and sometimes abruptly in ways that overwhelm entire regions. And because humans are drawn to coastlines for food, trade, and stable resources, much of our early activity took place in areas that are no longer above water. Whatever once existed in those spaces now lies beneath the ocean, hidden under layers of sediment, sand, silt, or in some cases buried so deep that finding it would require tools far beyond what we usually use for archaeological research. The idea of lost cities sounds dramatic when first heard, yet the scientific foundation behind it is straightforward. During the last ice age, so much water was locked in massive glaciers that sea levels were more than 100 meters lower than they are today. That created vast coastal plains where millions of people could have lived across generations. Rivers flowed differently. Shorelines extended far beyond their current boundaries. Bays that now exist were deep inland valleys. Islands that we see now were once connected to larger landmasses. When the ice sheets melted and sea levels rose, those low-lying regions disappeared beneath the water. That process wasn't a sudden, catastrophic wall of water sweeping across the land. It was a slow and steady advance that covered large areas over many centuries. Yet for the people living along those ancient coasts, even gradual changes could reshape their environment profoundly. It isn't difficult to imagine how communities would have responded to rising water. They would relocate gradually, moving inland as needed. Their settlements, farms, gathering places and structures, whatever forms they took, would be abandoned and eventually submerged. Because these ancient coastlines lie far offshore today, we rarely have the chance to explore them properly. The ocean makes excavation complicated. Visibility is poor. Sediments accumulate. Strong currents disrupt delicate layers. Marine organisms consume organic materials faster than any land-based conditions could. What remains often becomes scattered and very difficult to interpret. Only a small number of underwater archaeological sites have been discovered so far, and those discoveries already offer examples of settlements that once sat on dry land. They show that entire landscapes have vanished beneath the sea, taking with them not only the objects people used but also the broader context that would help us understand how they lived. When researchers find structures underwater, they have to work with conditions that limit how much can be examined. Even the most advanced underwater surveys only reveal small patches of the seafloor, and the depth of many ancient coastlines makes the work even more challenging. If we think about how human populations behave today, it becomes clearer why so many traces could be hidden underwater. People gravitate toward coasts because they provide access to fish, fresh water, flat land, and natural transportation routes. Throughout human history, coastal areas have supported dense populations. It is reasonable to assume the same was true in the distant past. Before agriculture became widespread, coastlines would have offered steady resources that allowed communities to flourish. When those coastlines shifted due to rising sea levels, those communities and their artifacts would have been submerged. Even if a settlement remained intact long enough to be preserved underwater, its long-term survival would depend on several rare factors: the water temperature, salinity, sedimentation rate, oxygen levels and biological activity all determine how quickly materials decay. Many types of organic matter break down quickly in seawater. Wood dissolves, textiles fall apart, bone can soften and fragment. Even stone structures can erode over centuries. Metal corrodes continuously. Over thousands of years, what remains becomes less and less recognizable. If something existed tens of thousands of years ago, the odds of it surviving in a recognizable form decrease dramatically. But it is not only submerged areas that hold hidden traces. Some lost cities never reached the ocean. They were overwhelmed by natural events that had nothing to do with sea levels. Rivers shift course over time. Floodplains accumulate thick layers of sediment. Volcanic eruptions bury entire landscapes in ash. Mudslides and landslides cover settlements completely. Over many centuries, accumulated soil and plant growth can make past structures invisible. What looks today like an unremarkable patch of land may contain several layers of human activity that have not yet been uncovered. One example, often used to illustrate how quickly cities can vanish, involves regions where rivers deposit large amounts of sediment. A settlement built near a river may be covered by several meters of material over just a few centuries. If the river changes course, the new delta deposits form elsewhere, leaving the old layers preserved but buried deep. Without a clear surface sign, archaeologists may never know that a settlement exists below. Without excavation, there is no way to tell, and excavation occurs only when someone has a reason to investigate a particular spot. Across the entire planet, countless such locations remain untouched. Deserts also hide their share of ancient cities. Sand dunes shift constantly. An entire settlement can be swallowed by dunes within a few years if conditions are right. The structures underneath may remain surprisingly intact for a while, but unless someone happens to find them during a brief window when the sand has moved aside, they remain unknown. Over long enough time frames, even stone structures under sand will crumble. As sand shifts again, the broken pieces scatter, the landscape smooths out. Unless someone digs in just the right place, the city is effectively invisible. And because deserts expand and contract over geological time, many regions that once supported thriving populations now sit under meters of shifting sand. Forests offer similar concealment, but through different processes. Dense vegetation grows over everything. A settlement abandoned for only a few decades can become completely covered by plant life. Within centuries, tree roots break apart walls and floors, soil accumulates, fallen leaves and branches cover pathways, moss and vines obscure any remaining markers. What remains eventually blends into the forest floor. Without cutting back vegetation or surveying with specialized equipment, no one would know what lies beneath. Volcanic regions provide some of the most dramatic examples. When an eruption occurs, ash layers can bury entire communities in a matter of hours. If the ash layer is thick enough, it creates an anaerobic environment that preserves materials well. That preservation is the reason sites like certain ancient towns are so famous today. But most volcanic events do not preserve sites in such ideal ways. Ash often mixes with rain, forming heavy mud flows that crush structures and scatter artifacts. Lava flows obliterate everything in their path. Over time, other ecological processes alter or remove the evidence further. In tropical regions, the combination of humidity, rainfall, and biological activity breaks down materials rapidly. A city built from wood in such an environment would not last long without constant maintenance. Even stone does not endure indefinitely in tropical climates. Heavy rains dissolve certain minerals. Plant roots force their way into cracks. Temperature fluctuations create stress in surfaces. Once a structure begins to weaken, it can collapse and become overgrown within decades. If centuries pass without anyone disturbing the site, the changes accumulate until what remains is indistinguishable from the surrounding landscape. All of these examples show how land-based settlements can disappear without leaving obvious traces. But when we combine the land-based factors with the possibility of submerged coastlines, the scale of potential hidden history grows considerably. It is not simply that some cities might be lost. Entire regions of human activity could be out of reach. This does not imply that those regions held large complex societies. Sometimes the lost evidence may represent small communities or temporary settlements. But even small communities contribute to the overall story of human development, and their absence creates gaps that are hard to fill. One of the challenges in exploring submerged regions is the depth at which ancient coastlines now lie. Some are only a few meters underwater, making them accessible for divers. Others lie dozens of meters below the surface. Some lie hundreds of meters deep due to tectonic activity. When a continental shelf drops or when the seabed sinks, the remains of settlements can end up far deeper than sea level change alone would suggest. Technology for exploring these depths exists, but using it for detailed archaeology is still a developing field. Most underwater surveys focus on shipwrecks or recent structures rather than ancient landscapes. Even when underwater features are discovered, interpreting them is difficult. The ocean floor is filled with shapes that appear artificial but are natural formations. Conversely, artificial structures can look like natural rocks after long exposure to water. Patterns that seem meaningful may turn out to be coincidental, and the lack of context makes interpretation harder. On land, archaeologists can dig through layers and understand the sequence of events. Underwater, layers can become mixed. Currents remove fine material. Biological activity alters surfaces. Without clear stratification, discerning the age and purpose of a structure becomes a challenge. Coastal erosion also removes evidence. Waves eat away at cliffs and shorelines. Storms rearrange sediments. In some regions, tsunamis have swept away entire layers of coastal land. Over thousands of years, the shoreline we see today may not resemble the one that existed when ancient communities lived there. What was once a large bay may now be a shallow sandbar. What was once a fertile delta may now be an underwater canyon. These changes complicate attempts to reconstruct where people lived and how they structured their communities. The ocean also acts as a recycler. Submerged structures collapse under pressure. Marine organisms break apart materials. Minerals accumulate on surfaces. Corrosion transforms metal into brittle fragments. Chemical reactions alter the composition of items. In some cases, objects dissolve entirely. After long enough periods, even durable artifacts can lose their shapes. A settlement that once had distinct features can become an indistinct patch of rock and sediment. This does not mean that ancient underwater settlements can never be found. It simply means that finding them requires a combination of fortunate conditions and focused effort. So far, only a small portion of the ocean floor has been mapped in detail, and much of that mapping focuses on geological features rather than archaeological ones. As technology improves, new tools may reveal more, but the scope of the task is enormous. The ocean covers most of the planet, and only a tiny fraction has been explored closely enough to identify subtle signs of past human activity. When we consider all these factors, rising sea levels, shifting rivers, expanding deserts, dense forests, volcanic events, erosion, sedimentation, and limited archaeological visibility, we begin to understand how many layers of human activity could be hidden from us. Not just from tens of thousands of years ago, but potentially from periods even older. The Earth has reshaped itself many times, and each reshaping moves or destroys whatever existed, while preserving only small portions under the right conditions. As we continue following this line of thought, more pieces of the puzzle come into view. Geological forces have erased more than they preserved, yet the few traces we do find give us reasons to keep looking deeper, because they hint at larger stories waiting to be uncovered. Instead of treating the lack of evidence as a sign that nothing existed, it becomes more reasonable to see it as a reflection of how much the planet has transformed. Nothing about the ground beneath our feet suggests how active it truly is unless we stop and examine the scale at which the planet operates. Most of the time the Earth appears still, dependable and consistent. The soil feels firm, the mountains hold their shape, rivers follow familiar paths. Yet this surface, which feels stable to us across a lifetime, is constantly being adjusted, stretched, lifted, buried, twisted, and rearranged. These changes may be too slow for our eyes to register, but they accumulate with unwavering persistence. If we had the ability to stand outside the passage of years and watch landscapes shift at accelerated speed, the ground would look far less quiet. It would resemble an enormous system in motion, continually rewriting itself without waiting for anyone's approval or awareness. That unending reshaping is crucial for understanding why so many traces of earlier human activity have disappeared. Even when a community manages to leave behind durable materials, they can only remain visible if the environment stays stable enough to preserve them. But the environment rarely stays stable. The Earth is not gentle with its own history. It does not intentionally preserve it or intentionally remove it. It simply follows physical processes that operate over long periods, and those processes determine how much of the past survives. One of the clearest examples of this is the movement of tectonic plates. The continents we see today are not fixed in place. They drift slowly across the planet's surface, carried by the movement of the underlying mantle. This drift is extremely slow from a human perspective, only a few centimeters per year, but over millions of years those centimeters become thousands of kilometers. Entire continents collide, split apart or rotate. Mountain ranges form and erode. Ocean basins open and close. The environments where people once lived are now entirely different from the environments that exist today. If a settlement existed on a piece of crust that later sank into a subduction zone, it would be dragged downward into the mantle and destroyed completely. No amount of excavation could retrieve anything from such a place. It would be as if nothing had ever existed there, and even places that do not sink are often transformed through uplift or folding. What was once a flat plain may now be a mountain range. What was once a fertile valley may now be buried beneath layers of rock that formed long after the valley disappeared. In each case, whatever structures or artifacts once existed in those regions are not simply buried but fundamentally altered or erased. Earthquakes add another layer of change. The sudden releases of energy shift entire landscapes in moments. Ground can rise or fall by several meters, rivers can be diverted, cliffs can collapse, fault lines can rupture open. A settlement located in an active seismic zone might be destroyed several times across centuries, and each destruction event scatters, buries, or obliterates the evidence. Over enough generations, people might rebuild repeatedly on the same spot, leaving a complicated mixture of layers. But if the region becomes abandoned, or if the environment changes, the final version of the settlement may become buried under the debris of earlier events. Volcanic activity reshapes landscapes even more dramatically. Eruptions can cover entire regions in ash or lava. Pyroclastic flows flatten forests and settlements in minutes. Lava hardens into new rock layers that can preserve the outline of certain structures but destroy everything inside them. Over thousands of years, these volcanic layers mix with new sediments, vegetation, and erosion. After millions of years, the volcanic rock might be uplifted, cracked, or buried by new deposits. In such a scenario, any traces of human activity, if they existed, would be nearly impossible to identify. The signature would be hidden within the complex layering of geological materials. River systems are another force that constantly rewrites the surface. A river rarely stays in the same channel for long. Over time, it shifts course through erosion and deposition. Floods lay down new sediment layers that bury older surfaces. Meanders cut through land and isolate patches of previous terrain. When a river changes position, the layers it leaves behind may hide entire phases of human activity. If a community lived along a riverbank thousands of years ago, their structures might now lie under several meters of sediment in a floodplain. Unless someone conducts careful analysis in exactly the right location, those remains stay hidden. Some rivers carve deep canyons over long periods. If people lived on the surface before the canyon formed, everything from that era has been eroded away. The landscape that existed when they lived there no longer exists at all. All the soil, vegetation and structures from that time have been carried downstream into the ocean, where currents and chemical processes further break them down. Nothing remains but the geological evidence of erosion itself. Glaciers reshape entire continents on timescales that are difficult to imagine. As they advance, they scrape the land beneath them, grinding rock into fine particles. Any traces of human activity in the path of a massive ice sheet would be crushed or buried. When glaciers retreat, they leave behind thick layers of sediment, creating new terrain that covers whatever existed previously. During the last glacial maximum, vast portions of the northern hemisphere were covered by ice several kilometers thick. If any evidence of earlier populations existed in those regions before the ice advanced, it would now be destroyed or deeply buried under glacial deposits. Mass movements of soil, such as landslides and mudflows, also sweep away traces of earlier presence. A single landslide can bury an entire settlement instantly. Over time, new vegetation grows on top, and soil layers accumulate. The deeper layers compact until they blend into the geological record. Without targeted excavation, these buried sites remain unknown. And even when they are discovered, the disturbance caused by the landslide can make it challenging to interpret what remains. Coastal erosion removes another category of evidence. Waves carve away cliffs and shorelines continuously. Many ancient settlements were built near coasts or along river mouths. Over thousands of years, those areas can erode so thoroughly that nothing recognizable remains. Cliffside structures fall into the sea, break apart and scatter along the ocean floor. Any organic materials decay quickly. Stones break apart under the wave action. Over time, even durable artifacts become part of the sediment. Wind erosion also contributes to the slow removal of traces, especially in arid regions. Wind carries fine particles that sandblast surfaces over time. Structures without regular maintenance gradually lose detail before collapsing. Once collapsed, their fragments break down further. Sand dunes can bury the site, but shifting winds can expose and rebury it repeatedly until the remaining materials weaken. Eventually the site becomes indistinguishable from the rest of the landscape. Another feature of Earth's constant reshaping is soil formation. Soil develops through the breakdown of organic matter and minerals. This process gradually creates layers that bury older surfaces. What was once a living space or pathway becomes a deeper layer of earth. In forested areas, thick layers of leaf litter accumulate each year, adding to the soil. Animals burrow and mix layers. Microorganisms break down organic material. If an artifact lies on the ground and is not buried by a sudden event such as volcanic ash or a landslide, it becomes part of the normal soil cycle. Over long periods, it may descend through the soil or break apart entirely. Climate cycles further complicate the preservation of human evidence. Regions that are dry today might have been humid in the past. Wet environments accelerate decay. They also encourage plant growth that breaks apart structures. Likewise, areas that are humid today might once have been dry. The conditions that allow preservation for one period may not last long enough for the next. Climate change across geological timescales ensures that very few environments remain stable enough to preserve traces consistently. In regions where permafrost exists, organic material can remain frozen for long periods, but permafrost is not permanent. When climates warm, the frozen ground thaws. As it melts, everything inside it begins to decompose. Buildings collapse, tools decay, natural bacteria break down organic components. The thawing process not only destroys preserved materials, but also alters the surrounding landscape by causing subsidence and shifts in the soil. As a result, whatever was once protected can be lost within a relatively short time. Beyond these surface processes, chemical reactions within soil and rock can erase delicate traces. Acidity in soil dissolves bone. Basic soils can break down metals. Minerals can leach into materials and alter their structure. Over long periods, these chemical changes can render artifacts unrecognizable. A tool or structure may remain in place but become so altered by mineral replacement that it looks like an ordinary stone. Biological activity also contributes to the erasure of the past. Plant roots search for nutrients and water, forcing their way into cracks in stone and disturbing layers of soil. Over time, they can split apart walls and foundations. Burrowing animals mix sediment layers and scatter small artifacts. Microorganisms break down organic materials. All of these biological forces are active across the entire planet, working continuously to reshape the layers that contain evidence of earlier activity. Even with all these forces at work, a surprising amount of material still survives long enough for archaeologists to find pieces of it. But the key word is pieces. The record is rarely complete. For every well-preserved site, there are countless others that have been altered or erased by the planet's ongoing processes. That imbalance means the absence of evidence cannot be taken as evidence of absence. It simply reflects how thorough Earth's reshaping can be. There's also the issue of access. Many parts of the Earth's surface remain unexplored by archaeological teams. Dense forests, remote mountain ranges, deep valleys, thick deserts and underwater regions all contain potential sites that have not been investigated. Some regions are politically unstable or difficult to reach. Others lack funding for detailed study. Even in accessible areas, excavation covers only a tiny fraction of the ground. Most archaeological work focuses on small sites where evidence is already visible. The deeper layers, hidden beneath meters of soil or sediment, remain untouched. Considering all of these factors together makes it easier to understand why so much of the past has vanished. The Earth is not a static archive. It is a dynamic, shifting environment that constantly recycles itself. Even without dramatic events, slow processes alone are enough to erase long stretches of human history, and when sudden events are added to those slow processes, the erasure becomes even more complete. This realization doesn't diminish the significance of what remains. Instead, it broadens our understanding of what may have existed outside the narrow window we currently study. There is no reason to assume that earlier societies lacked complexity simply because their traces have not survived. Complexity is not the same as permanence. A group may develop intricate knowledge, sophisticated practices, or stable organisational structures without building anything that endures on geological timescales. And if they lived in regions prone to natural reshaping, the likelihood of preservation becomes even lower. The physical forces that erase the past are the same forces that create new environments. They form new coastlines, carve new valleys, and build new mountains. And with every reshaping, more of the earlier world becomes part of the deep, hidden layers that require careful work to uncover. Across the span of human history that we can actually study, there are many societies that manage to grow, flourish, influence entire regions, and then disappear so completely that only scattered hints remain today. Their absence from everyday awareness is not because they were insignificant or brief, but because the physical world did not preserve enough of their presence for later generations to understand fully. When we look at these examples, they provide a practical reminder that civilizations do not need to be ancient by geological standards to fade almost entirely from sight. Even societies from only a few thousand years ago can slip into obscurity with surprising ease, and if that can happen in relatively recent times, the possibilities for what might have existed earlier become easier to imagine. Instead of beginning with the most famous examples often used in discussions like this, it may be more helpful to start with societies that once held stable populations, but relied heavily on materials that do not survive well. In certain regions, people built their homes from plant fibres, unfired clay, animal skins, or wood. These materials make perfect sense when considering climate, resources, and cultural practices, but they do not leave durable traces. After only a few decades of abandonment, a settlement made primarily from such materials becomes unrecognisable. After a few centuries, it effectively disappears. Archaeologists sometimes find patterns in the soil that reveal where buildings once stood, but that type of evidence requires the kind of careful, detailed excavation that only occurs when researchers already suspect a site is present. There were also societies that expanded across large regions without centralising into cities. They left behind networks of temporary settlements, seasonal camps, or small clusters of structures that were rebuilt periodically. These patterns do not produce imposing ruins. They do not leave behind monuments. Instead, they leave charcoal, broken tools, and faint disturbances in the soil. If those areas experience natural changes such as floods, forest growth, or shifting dunes, even those subtle traces are easily erased. The result is a culture that may have lasted for thousands of years, but now appears only as scattered artifacts that are difficult to connect into a clear picture. Another category of civilizations that nearly vanished includes those that experience sudden or gradual decline due to environmental changes. A shift in climate can alter rainfall patterns, temperature ranges, and resource availability. When a region becomes less capable of sustaining large populations, people move on. If drought persists for long enough, farmland becomes unsuitable. Rivers dry up, lakes shrink. Once the population leaves, the buildings they constructed fall into disrepair. If the region later becomes dry enough, wind erosion strips away the upper layers. If it becomes humid, plant growth and soil formation take over. In either case, the society that once thrived there becomes difficult to identify centuries later. Some societies were disrupted by other groups moving into their regions. This does not always involve conflict. Sometimes it simply reflects natural migrations. A group arrives, settles, and uses the remains of earlier structures for their own purposes. Over generations, they modify or rebuild parts of the settlement. Layers merge. older structures are dismantled. Eventually, the original group's identity blends into the incoming one, leaving behind only a few artifacts that are difficult to assign clearly. Without written records, archaeologists must rely on pottery styles, tool types, or shared patterns in settlement layout to identify the earlier population. If those materials were not durable, or if environmental factors scattered them, then the earlier society fades from view. This pattern can be seen in several regions where archaeologists discovered evidence of entire cultures only after detailed study. In some cases, early researchers believed an area had been sparsely populated, only to later discover through remote sensing or excavations that complex societies once lived there. Often these discoveries happen because someone notices small anomalies in the landscape. Slight mounds, subtle soil differences, or unexpected artifacts in ploughed fields. These clues lead to systematic studies, which then reveal networks of settlements previously unknown. If those clues had not been noticed, the existence of those societies might have remained hidden. One useful example comes from regions that developed elaborate agricultural systems without building large stone structures. Terracing, irrigation channels and storage pits can transform landscapes, but these modifications are sometimes subtle. When terraces erode or irrigation canals fill with sediment, they blend into the surrounding terrain. Without targeted research, they appear as natural features, and because these societies often use perishable materials for homes and communal spaces, their settlements do not leave the kind of ruins that attract attention. Yet these communities supported significant populations and developed knowledge suited to their environments, knowledge that becomes clearer only when careful fieldwork uncovers faint patterns beneath vegetation or soil. There are also societies that left behind structures made of durable materials but in small quantities. These structures might be scattered or located in areas that are difficult to reach. Without consistent discoveries, researchers might assume the region was sparsely inhabited, but when remote sensing technology such as LiDAR or ground-penetrating radar are used, entire networks sometimes appear in the data. Dense forests hide old roads, pathways and foundations. Once these features are recognized, archaeologists can piece together the broader patterns of life that existed there. Yet even with these tools, only a small portion of the world has been surveyed in detail. Many regions remain hidden beneath thick vegetation, meaning countless societies may still be undetected. Floodplains offer another example of how civilizations can disappear. When a river floods repeatedly over centuries, it deposits layers of sediment that bury older surfaces. If a settlement existed near such a river, its traces might lie several meters below the present ground. Sometimes the only way to uncover these layers is through deep excavation, which is expensive and rarely undertaken unless specific evidence suggests its necessity. As a result, many settlements remain hidden, waiting for the chance event of construction, erosion, or a research project to reveal them. And if deeper layers are never exposed, the society that once occupied that area remains unknown. Some civilizations are known only through the remains of burial sites rather than settlements. Burial practices often involve locations separate from living spaces. When researchers find a burial site, they can learn about the people who once lived in the region, but they may not find the actual settlement if it was made from less durable materials or if the environment has changed. This separation creates gaps in the historical narrative. We know people existed, but we do not know how they organized their society, built their structures, or moved across the landscape. Without those details, the broader context remains incomplete. In certain parts of the world, small stone structures or earthworks suggest that societies with organized labor once lived there. These features may be isolated or scattered over wide areas. Without additional evidence, it is difficult to determine how large or complex these societies were. Sometimes the structures represent small communities. Other times they may be the remnants of a broader interconnected system. The lack of clear evidence forces researchers to interpret cautiously, often leaving the full picture unresolved. there are civilizations that developed unique forms of writing or symbolic communication, but left behind only a few examples. If those symbols appear on fragile surfaces such as wood or bark, survival is unlikely. Even if inscriptions were carved into more durable materials, they may be too scarce to decipher. When archaeologists find a script without a clear context or bilingual translation, its meaning remains unknown. This has happened several times in the archaeological record. Without understanding what the inscriptions say, the culture behind them stays mostly silent. Their laws, beliefs, trade patterns, and daily activities become impossible to reconstruct, leaving only hints of a more complex system. Some societies declined rapidly due to resource exhaustion. Agricultural lands can become depleted after long periods of cultivation. Irrigation systems can fail if silt accumulates faster than maintenance can handle. Forests can be cleared beyond the point of recovery. When these stresses accumulate, populations may relocate to more sustainable regions. They carry some of their cultural practices with them, but not always their full identity. Over time, their original homeland becomes abandoned. If erosion or vegetation covers the area, the society that once thrived there becomes difficult to detect. There are also examples of societies that collapse due to disease. A sudden epidemic can reduce populations dramatically in a short period. If the remaining people disperse, the settlement loses its ability to maintain structures or record events. Buildings weaken, farms decline, and the physical signs of the community fade. Without survivors to preserve records or maintain sacred sites, the society's identity dissolves. Archaeologists might uncover remnants later, but without clear continuity, the reconstruction remains partial. In other cases, societies didn't collapse but gradually merged into neighbouring groups. Cultural blending occurs frequently in human history. Over generations, one identity absorbs another through intermarriage, shared practices, or trade. When this happens, the earlier identity becomes less distinct. Written records may not survive, or they may never have existed. Archaeologists find artifacts from the earlier group, but the cultural meaning is lost because the identity has merged into something larger. Without a clear boundary, the society becomes difficult to define. Many well-known examples of nearly forgotten civilizations were rediscovered only by chance. A road construction project might reveal buried pottery. A farmer's plough might unearth a stone tool. A riverbank might erode just enough to expose a wall. These chance discoveries lead researchers to conduct more systematic studies. Once they begin, they often find that a thriving culture once occupied the area. Yet these discoveries reflect only a small fraction of what might exist. If a region has not been disturbed, the buried remains remain hidden. If erosion has removed the upper layers, the site may be gone forever. Even when a civilization leaves behind recognizable artifacts, interpreting them is not always straightforward. Tools may be scattered by natural processes. Materials may be incomplete. Pottery pieces may not reveal the full range of styles that existed. Without complete structures, it becomes difficult to understand how settlements were arranged. And without written records, we lack direct insight into the society's organization, beliefs, and developments. These gaps reveal how easily even well-established civilizations can fade into the background of history. To understand how many civilizations rose and fell with limited traces, it helps to note that many famous societies we know today were nearly forgotten until modern research uncovered them. Large structures hidden under jungles or deserts remained unknown for centuries. Trade networks that stretched across continents left behind only partial records. Sophisticated metallurgical traditions were discovered only through small fragments of tools or smelting sites. Each time a new discovery emerges, it pushes the boundary of how much we assume we know about the past. And with each discovery, we learn that earlier assumptions often underestimated the complexity of human activity. This pattern suggests that much more may exist beyond what we currently recognize. If societies from only a few thousand years ago have nearly vanished, then societies from tens of thousands of years ago would be even harder to detect. And if human-like species existed for hundreds of thousands or millions of years before that, any societies they developed would be even less likely to leave clear evidence. The absence of surviving structures, artifacts or writing does not imply the absence of organised societies. It simply reflects how readily the world transforms itself and how easily human presence can fade when conditions are not favourable for preservation. People have always tried to make sense of their surroundings by building stories that carry meaning forward, even when the original events behind those stories are no longer clear. When physical evidence disappears, traditions and memories often continue in some form. They change gradually as generations repeat them, adjust them, or attach new interpretations to old ideas. Across different regions and time periods, these stories weave together experiences, environmental events, and cultural lessons, creating accounts that are not precise historical documents, but still reflect something real that once happened. Looking at myths through this lens doesn't require assuming they describe literal events. Instead, it allows us to consider how certain memories might have persisted in symbolic or simplified ways long after the original circumstances faded. There is a practical reason myths endure even when physical evidence does not. Stories can survive mobility. A group can migrate, lose its tools, abandon its settlements, or face a disaster, but its stories can be carried internally. A community's knowledge of ancestors, origins, dangers, and helpful practices travels with them through speech. That portability gives myths a durability that physical artifacts lack. A tool left behind decays, a structure collapses, organic materials rot. But a story can move from one region to another as long as someone remembers it well enough to teach it to others. This makes myths a unique form of preservation that remains active even when the environment reshapes or removes the material signs of earlier cultures. Consider how many myths around the world describe large-scale floods, dramatic environmental shifts, or lands disappearing beneath water. These accounts appear in regions separated by oceans, mountains, and thousands of kilometres. While each culture tells its own version, the shared theme raises an important point. Floods were common in early human environments, especially in the period following the last ice age, when rising sea levels gradually submerged coastal areas. People living near rivers, lakes, or coastlines would have witnessed these changes. For a community dependent on a stable shoreline, the slow encroachment of water might have been perceived as a major event that reshaped their world. Even if these changes took place over generations, their collective memory could compress the experience into a story that described a single transformative episode. Myths also preserve memories of geological events such as volcanic eruptions, earthquakes, or the sudden appearance of new land following tectonic activity. In some cases, modern geological studies have confirmed that the events described in myths align with known natural occurrences. That doesn't mean every part of a story matches the historical event exactly. It simply shows that the stories contain embedded knowledge. When a volcano erupts, the visual impact is enormous. Ash darkens the sky, rivers change course, settlements are destroyed. In the aftermath, the people who survive may relocate and tell the story of what happened. Over centuries, symbolic or religious interpretations may be added. But at the core, the story may reflect a real event. Across different cultures, stories of lost lands appear frequently. Some describe entire regions sinking into the sea. Others mention communities being forced to move inland after coastlines shifted. These stories may not point to a single lost continent or an advanced civilization. Instead, they might represent memories of local or regional changes that were significant enough to define a generation's experience. Coastal erosion, rising water, storms, and tectonic shifts all alter landscapes. When a region that once supported a community becomes uninhabitable, the people who lived there may interpret the change as something dramatic. their descendants may retell it as a story of a land taken away or swallowed. It's also important to recognise that stories evolve over time. A myth told 1,000 years after an event may retain some elements of the original memory while introducing entirely new layers. The symbolic aspects of the story may grow stronger while the literal elements weaken. A practical warning about flooding might become a lesson about humility. A memory of migration might become a tale about an ancestral journey guided by spiritual forces. These changes do not erase the historical roots of a story. They simply transform it into something that serves the needs of each generation, blending memory with meaning. In many societies, myths explain where people came from, how they learned certain skills, or why they follow specific practices. Some of these stories likely reflect earlier cultures that taught useful techniques before disappearing. When a later culture inherits a practice but not the full context behind it, a story may form to explain the origin. Over time, that story becomes part of the population's identity. The original group that developed the technique may leave no physical traces, but their influence survives in the practices and stories that later groups maintain. Another way myths act as echoes is through the preservation of environmental clues. A story might mention an animal that no longer lives in the region, a plant that once grew there, or a landscape that has since transformed. When researchers compare these details with what geology, paleobotany, or zoology reveals about the environment at a particular time, patterns occasionally emerge. These patterns suggest that the myth contains information from a period long before any written record. This doesn't turn myths into flawless records, but it shows that they can retain fragments of real experiences. Some societies describe encounters with earlier groups who lived differently, used unfamiliar tools, or inhabited the region before them. These stories sometimes characterize the earlier inhabitants as giants, spirits, ancestors, or mysterious people who vanished. From a practical standpoint, these descriptions may reflect encounters with a distinct population that later disappeared or was absorbed. Because early societies lacked precise terminology for cultural differences, they expressed those differences symbolically. What remains today is a stylized account that hints at these interactions, but doesn't preserve the full details. There are also stories about large structures built long ago by unknown people. In some regions, later populations encountered ruins they did not recognize as belonging to their own ancestors. Without written records, they created explanations based on what seemed plausible within their worldview. Some myths attribute the structures to supernatural beings. Others say they were built by an earlier group that vanished due to a mistake, a conflict, or a judgment. These stories often carry moral themes, but they also hint at real encounters with physical remnants of earlier cultures. Not all myths describe dramatic events. Some simply preserve patterns of knowledge that guided survival. Stories about navigation, star patterns, seasonal cues, or animal behaviour reflect long-term observations. When people tell these stories repeatedly, they embed knowledge in a narrative framework. That allows generations to remember information effectively even when conditions change. In some parts of the world, myths about star positions helped people track migrations, determine planting times, or navigate across large distances. Although these stories may not provide historical details about earlier societies, they preserve methods those societies developed. Another notable feature of myths is how frequently they refer to a time when the world was different in ways that are consistent with environmental shifts. Many stories describe landscapes where rivers flowed differently, mountains were smaller, forests were larger, or coastlines stretched further. In some cases, geological research confirms that these descriptions align with known environmental conditions from earlier periods. For example, a story about a long-vanished lake might match the location of an ancient lake bed discovered later. This suggests that the story preserved a memory of the landscape as it once existed, even if the details have changed. Some myths describe interactions with animals that were present in the region long ago but are now extinct or rare. When such stories appear from cultures that have no living memory of these animals, It raises the possibility that the stories preserve distant recollections of earlier conditions. This is not definitive evidence of anything beyond the interaction itself, but it illustrates how myths can carry information across long stretches of time. In many regions, myths form a link between cultural identity and the land itself. They describe how certain mountains, rivers, or valleys were formed. Some of these stories align with geological events such as landslides, volcanic eruptions, meteor impacts, or rapid environmental changes. Even when the stories describe these events in symbolic or personified terms, they often reflect a real phenomenon observed at some point in the past. As these stories pass through generations, they remain anchored to specific locations, giving researchers a way to investigate potential correlations. One challenge with interpreting myths as historical echoes is determining where memory ends and symbolism begins. Stories are not meant to record events with perfect accuracy. They are designed to convey meaning. But meaning often emerges from the real experiences people have. If a society endures repeated seasonal flooding, it may form stories about water spirits, river beings, or the consequences of ignoring environmental warnings. If a society survives a volcanic eruption, it may frame the experience as a conflict between powerful forces. Over time, the story becomes more symbolic, yet the root event remains embedded within it. When considering forgotten cultures, myths sometimes provide hints about groups that left a little physical trace. These hints may describe a people who lived differently, used unfamiliar techniques, or occupied the region before the current inhabitants. The story may portray them as strange or distant, reflecting the uncertainty of memory rather than literal characteristics. But such accounts suggest that earlier groups existed and left an impression strong enough to persist in cultural memory even after their material presence faded. In regions where archaeological evidence is sparse, myths offer a rare window into the past. For example, some cultures maintain stories of ancestral homelands that no longer match the current environment. If those stories mention features consistent with an earlier climate period, they may reflect migrations that took place long before writing. A group might recall a land where rivers were abundant, forests were thick, or animals now extinct were common. These descriptions may represent distant memories of a landscape that no longer exists. Some stories describe journeys across regions that would be difficult to traverse today. These stories may reflect conditions that made the journey easier in the past, such as lower sea levels, cooler climates, or different vegetation patterns. As environmental conditions changed, the journey became more challenging, but the story remained. This contributes to the idea that myths preserve information across long stretches of time, even when the physical world changes around them. There are also myths that speak of technological abilities or cultural practices that seem unexpected for the time. While it's easy to interpret these as exaggerations, they may reflect real innovations or methods that were lost. For example, a story about large-scale construction might reflect techniques that a society developed but later abandoned. Without durable materials, those techniques would leave little trace. Over time, the stories remain, but the physical evidence disappears. It is important to approach myths carefully. They cannot serve as scientific proof of forgotten civilizations. They are not detailed historical accounts, but they can point toward earlier experiences that left impressions on the people who lived through them. When combined with archaeology, geology, and anthropology, myths help researchers identify patterns that might otherwise go unnoticed. What makes myths valuable in the context of forgotten cultures is not the literal content, but the fact that they represent persistent memory. They show what people considered important to remember. They reveal how communities understood change. They provide a sense of what affected their ancestors deeply enough to be repeated for centuries. Looking at how dramatically Earth's climate has shifted across deep time makes it easier to understand how many human stories may have unfolded in environments we can barely imagine today. The world we live in now is only one version of Earth, shaped by a particular set of temperatures, sea levels, rainfall patterns, coastlines, and biological systems. If you go back tens of thousands, hundreds of thousands, or millions of years, the conditions look entirely different. Ice sheets stretch across continents. Rainforests spread where deserts now exist. Deserts expand across areas that later become fertile. Sea levels swing up and down. Oceans warm and cool. Rivers carve new routes. Ecosystems appear and disappear. These shifts didn't happen overnight, but they changed the world profoundly. And the people living through those shifts, whether they were Homo sapiens, earlier human species, or groups we have not yet identified, would have adapted in ways that might leave very little trace today. The last ice age often comes to mind first because it is the most recent major climate event. But even within that single period, the conditions varied significantly. There were warmer intervals when glaciers retreated, and colder intervals when they advanced again. These fluctuations altered landscapes repeatedly. Vast stretches of land that once lay beneath ice became exposed during warmer periods, allowing plants and animals to move in. Human groups followed food sources into these newly accessible regions. When glaciers advanced again, those same regions became uninhabitable. Any traces left behind would have been crushed under the weight of ice, or scattered by glacial movement. During the coldest parts of the last ice age, sea levels dropped dramatically. Coastlines extended far beyond their modern boundaries. Valleys that are now submerged held rivers, forests, and plains. These areas would have been appealing for human habitation. They offered access to marine resources, flat land for seasonal camps, and routes for migration. As temperatures warmed and glaciers melted, those landscapes disappeared under rising water. If communities lived there, and there is strong reason to believe many did, most of their traces would now lie beneath layers of ocean sediment. On the other hand, during warmer periods in Earth's history, sea levels rose not by tens of meters but by much more. Rainforests expanded farther north and south. Large animals roamed areas that today support completely different ecosystems. Regions currently arid were once lush, and in warm periods much earlier than the last ice age, the continents held forests where now there are plains or deserts. Human ancestors living in those regions would have built structures from materials suited to their climates. Because many of those materials were organic, they would not survive for hundreds of thousands of years. Without preservation in tar pits, caves, or other unusually protective environments, the physical evidence would decay too quickly. Looking further back, long before Homo sapiens emerged, Earth went through cycles of extreme climate known as glacial and interglacial periods. During glacial periods, ice sheets spread. During interglacial periods, warm climates returned. These cycles repeated many times over millions of years. Each cycle reshaped coastlines, redistributed rainfall, and altered migration patterns. Early humans, species such as Homo heidelbergensis, Homo erectus, and others, lived through these changes. Their ways of organizing communities, building structures, or establishing territories might not resemble ours, but they were undoubtedly shaped by their environments. Whatever form their societies took, the physical evidence would have faced the same challenges of erosion, decay, and environmental transformation that affect more recent traces. While we often picture ice ages as harsh and unforgiving, many regions on the edges of ice sheets were rich ecosystems during these times. Large mammals flourished. Plants adapted to colder climates created open landscapes ideal for hunting. People living in these areas developed strategies and tools suited to the conditions. Their settlements might have consisted of animal hide shelters, wooden structures, or temporary camps that left only light imprints. These materials vanish quickly once exposed to moisture, freeze-thaw cycles, or microbial decay. The idea that entire lifeways could disappear without recognizable traces is consistent with what archaeologists observe in many early sites. Warm periods offer another set of challenges for preservation. In tropical climates, decay happens rapidly due to humidity, rain, and biological activity. Termites consume wood. Fungi break down plant fibers. soil organisms accelerate decomposition. If a community built homes from leaves, branches, or lightweight wood, those structures would leave almost nothing detectable after a few centuries. Even if the community remained in the region for thousands of years, the archaeological signature might be barely visible. Wet climates require specific conditions for preservation, such as deep mud, peat bogs, or caves. Without these protective environments, the physical evidence dissolves quickly. Another aspect to consider is how population distribution changed with climate. During cold periods, people may have concentrated in areas with stable resources. During warm periods, they may have spread out more widely. These patterns affect how much evidence accumulates in any given location. In a dispersed population, only small quantities of material might be left behind at each site, and if those sites were later affected by erosion, flooding, or vegetation growth, the evidence might become indistinguishable from natural deposits. Ice Age migrations also complicate preservation. As glaciers advanced and retreated, people moved repeatedly. That mobility means many early settlements were temporary. Even if a group stayed in an area for several generations, the structures they used might have been rebuilt frequently with fresh materials. Rebuilding leaves few durable traces. When archaeologists look at very old sites, they often find only scattered lithic tools or fragments of bone. These materials survive because they resist decay better than wood, fibre, or hide. But the presence of tools alone doesn't reveal how people lived, organised their communities, or interacted with their environment. In warm periods, rising sea levels didn't just submerge coastlines. They also created islands, reshaped river systems, and shifted the boundaries of fertile regions. These changes influenced where people lived and how they moved. Some areas that were once ideal for settlement became marshlands, others became dense forests, still others turned into deserts. The shifting conditions pushed groups to adapt repeatedly. Each adaptation left a brief physical footprint that could be erased by the next climate shift. Thinking about these cycles gives us a clearer sense of how many civilizations might have existed in earlier periods without leaving recognizable evidence behind. A society could flourish during a warm period, building homes suited to the climate, gathering food from a stable environment, and passing knowledge through generations. But when a sudden shift occurred, whether due to temperature changes, droughts, floods, or ice expansion, the population might have moved or fragmented. Without durable materials or lasting structures, their presence could be forgotten entirely. Even in regions with better preservation conditions, climate cycles complicate interpretation. Layer after layer of environmental deposits can obscure human occupation. If a warm period creates thick vegetation, soil accumulates rapidly. If a cold period later strips vegetation away, erosion removes material. These alternating patterns create a record that is difficult to read. A settlement from one climate phase may be buried deep under later deposits. If erosion then cuts through the area, fragments might appear out of order. Without a clear stratigraphy, identifying the age and context becomes challenging. The shifting climate also altered the movement of animals that early humans depended on. Herd migrations changed direction or timing depending on environmental conditions. Early communities followed these herds across valleys, plains, and coastlines. Their settlements were organised around the behaviour of the animals they hunted. When climate shifts altered migration patterns, these communities adjusted accordingly. That fluidity leaves little behind in terms of structures. Lithic tools remain, but everything else fades. There is also the question of how early humans interacted with one another during climate-driven migrations. Groups may have encountered others with different traditions or knowledge. These interactions could lead to exchanges of ideas, tools, or practices. Some of these interactions might form the basis of later myths, as discussed earlier. Others may have influenced the development of technologies that were later lost. Climate cycles would not only shape the environment, but also the cultural connections between groups. Some of those cultural networks may have been extensive even if they left minimal physical evidence. When thinking about possibilities for civilizations that could have existed in warm periods much earlier than the last ice age, it's important to remember that human-like species lived for millions of years. While they may not have built large stone structures or developed writing, they had long periods in which to adapt, innovate, and form social systems. The climate provided opportunities for expansion during warm phases and challenges during cold phases. Over such long durations, many lifeways could have developed and disappeared repeatedly. Looking at specific warm intervals, some eras in Earth's history were significantly warmer than today. Forests extended into regions that are now cold or dry. Prehistoric lakes covered large inland basins. These environments offered rich resources for early human ancestors. If communities existed in these areas, their settlements may now lie beneath deserts, collapsed under dried lake beds, or hidden under dense sediment layers. Geological studies reveal some of these ancient environments through fossil distributions, chemical signatures, and sediment cores. But the human presence remains largely absent from the record. That absence doesn't necessarily mean humans weren't there. It means the evidence did not survive. When the climate cooled again, ice sheets advanced, lowering sea levels and exposing vast stretches of land. These land bridges connected continents, allowing migrations between areas that are now separated by oceans. Human movement across these land bridges may have created cultural networks that left few physical traces. Once the ice melted and sea levels rose again, these regions disappeared beneath the water, taking their evidence with them. It's also worth considering that not all civilizations need to resemble our modern idea of one. They do not need large cities, monumental structures, or extensive trade routes to be significant. A civilization is a stable, organized community with shared cultural practices. A well-adapted group living in a climate phase for thousands of years could meet that definition without leaving behind ruins. Their knowledge would be passed orally. Their structures would be built from local materials. Their tools would be suited to the environment. When the climate shifted, the group might adapt or disperse, leaving only a minimal material footprint. Because climate cycles create so many opportunities for both flourishing and disappearance, they invite us to imagine how many different human stories could lie hidden beneath the environmental transformations. These stories do not need to involve advanced technology or dramatic achievements. They simply need to reflect generations of people adapting to changing conditions in ways that made sense within their time. Most discussions about missing civilizations usually stay grounded in archaeology, geology, and climate. But there is another angle that adds an interesting layer to the puzzle. It comes from a question normally applied to the night sky rather than to the Earth beneath us. The Fermi paradox is often summarized as a tension between probability and silence. If the universe is vast and old enough to produce numerous advanced civilizations, then why do we see no clear evidence of them? Shifting that idea closer to home raises a related question about our own past. If Earth had so much time before modern humans existed, and if earlier species or earlier forms of society had opportunities to develop stable, organized communities, then why do we find so little evidence of them? This doesn't mean we expect ancient civilizations to match our modern capabilities. The question simply highlights the gap between what seems possible over immense stretches of time and what we can actually see in the physical record. Starting from that point, it becomes helpful to examine why we expect to find anything at all. Human intuition tends to assume that if something existed, especially something as significant as a civilization, it would leave behind unmistakable signs that persist across ages. Yet the examples already discussed show that even societies from only a few thousand years ago can leave behind almost nothing. Traces fade, landscapes shift, evidence dissolves, and materials degrade. When we apply this knowledge to earlier periods, the expectation of finding recognizable remains becomes less reasonable. But the curiosity doesn't disappear. Instead, it becomes a steady question that sits quietly in the background. Given all the time Earth had, is it plausible that other organized societies rose and vanished without leaving clear evidence? The first part of this question concerns the scale of time itself. Earth has existed for more than 4 billion years. Life has existed for most of that time. Complex life has existed for hundreds of millions of years. Human-like species have existed for several million years. Modern-looking humans have existed for around 300,000 years, and complex societies with writing have existed for only a tiny fraction of that. When numbers like these are placed alongside one another, it becomes obvious that the slice of time we actually understand is extremely narrow. The span in which evidence survives well enough for archaeologists to find recognisable structures is even narrower, and the span in which writing preserves information is narrower still. If we apply the logic of the Fermi paradox to this timeline, the question becomes simpler. Earth had immense time and numerous species capable of tool use, problem solving and social cooperation. Many of these species lived in environments that could support long-term stability. Over such long stretches, could organised societies form more than once? If they did, would we expect to see them clearly today? Or would their traces blend into the shifting layers of geology and climate in a way that makes them indistinguishable? Before addressing whether we should expect to find anything, it helps to look at the types of evidence that survive easily. Stone tools, bones, and durable carvings have the highest chance. But even these require favourable conditions. A single flood, wildfire, volcanic eruption, or decade of exposure can remove them. When early humans carved stone, they left behind tools we can still find. But earlier species may have built shelters or created structures from materials that didn't survive. Plants, wood, hides, and woven fibres vanish quickly. If a society organised itself in a way that relied mostly on such materials, it might leave behind very little. There is also the possibility that earlier societies did not expand to the scale modern humans eventually reached. A stable, organised group could live in small populations, migrate seasonally, and maintain complex traditions without building large settlements. In such cases, the archaeological visibility would be low. Without dense construction, heavy resource use, or distinctive waste patterns, the physical traces might blend seamlessly into natural surroundings. If later geological processes removed or rearranged the layers where those traces once existed, they would be difficult to identify. Another aspect of the Fermi-like question revolves around detection capability. For extraterrestrial civilizations, we assume our tools are not advanced enough to perceive faint signals. For ancient Earth societies, the limitation lies in how much of the planet we've actually examined. Only a small fraction of Earth's surface has been studied through excavation. Underwater territory is even less explored. Deep layers beneath modern cities, farmland or forests remain untouched. Many regions once suitable for habitation lie beneath sediment, ice or dense vegetation. If something existed there, we would not know unless someone happened to dig in exactly the right place. Even when researchers find tools or structures, determining their age can be challenging. Materials shift from one layer to another. Sediments get disturbed by natural processes. Bones move with soil cycles. If a layer mixes artifacts from different time periods, interpretation becomes complicated. Without clear context, archaeologists must rely on patterns, chemical signatures, and comparisons. If a tool appears isolated in a context that lacks other features, it may not reveal much about the society that produced it. This fits into the broader question. If Earth had the time and opportunity, then why do we not see more evidence of earlier transitions from simple to complex? The answer may be that complexity does not always translate into durability. A society can be advanced in knowledge or structure while leaving behind materials that don't survive. Knowledge passed orally leaves no mark unless it becomes encoded in material culture. Techniques for constructing shelters, navigating landscapes, or processing resources may not involve tools that last long enough to be discovered. When thinking about earlier societies, it may help to compare them to small-scale communities that existed far more recently. Many such groups lived for thousands of years with stable cultures, advanced ecological knowledge, and sophisticated social systems. Yet because they built with materials suited to their environments, their settlements left behind minimal durable traces. If we imagine similar groups existing much earlier, it becomes easier to understand how entire lifeways could disappear without leaving a recognisable archaeological footprint. Another part of the Fermi-like reasoning is the assumption that if earlier societies existed, they would have developed technologies that leave behind unmistakable artefacts. This assumption may not apply. Technological direction depends heavily on environment, resources, needs, and available materials. Early societies may have pursued innovations suited to their surroundings. In a region rich in plants but lacking stone, tools might have been made entirely from organic material. In a region with abundant game and stable seasons, there would be less pressure to develop long-lasting structures, and in some regions the climate itself would determine what materials were practical. Even when metal deposits existed, the knowledge required to process them may have been difficult to develop without particular environmental cues. If we set aside assumptions about what civilization should look like, the question becomes less about advanced technology and more about persistence of cultural patterns. A society that lasted tens of thousands of years, adapted successfully to environmental changes, and developed complex social knowledge would still qualify as a civilization even if it did not build permanent structures. And if such a society disappeared due to climate shifts, migrations, or geological events, the physical evidence could be minimal. The other side of the paradox concerns the environments where evidence is least likely to be preserved. Warm, humid regions destroy organic material rapidly. Coastal regions flood and erode. Forests grow over landscapes and grind structures down. Deserts shift sand dunes over settlements. Ice sheets crush and remove everything beneath them. If an earlier society lived in one of these regions, its traces would have very little chance of surviving long enough for modern researchers to discover. And because so many early human and human-like species lived in environments that promoted decay rather than preservation, the absence of evidence may reflect environmental limitations rather than historical emptiness. There is also the issue of visibility through time. The deeper we go into the past, the more the geological record becomes compressed, altered, or mixed. Rocks fold, sediments shift, heat and pressure transform materials. Fossils that do survive do so under very specific conditions. For human evidence to survive millions of years, it would require exceptional preservation. If earlier societies existed in periods when sediment layers were unstable or frequently disturbed, their remains would not survive long enough to fossilize. And even if they did fossilize, distinguishing cultural artifacts from natural features becomes difficult when the material has undergone mineral replacement. If we ask the Fermi-like question, if earlier civilizations existed, where are the signs? We must also consider the limitations of our assumptions. We expect signs to be obvious, but most evidence from recent history shows how subtle many signs truly are. A single scattering of stone flakes can represent generations of activity. A faint soil discoloration can reveal the outline of a structure. A small number of hearths can represent a thriving community. These subtle traces require detailed, targeted excavation. Without such excavation, they remain invisible, and because the Earth's surface is vast, the chance of finding these subtle traces by accident is very low. Another dimension comes from the fact that our knowledge expands gradually. New technologies such as LiDAR have revealed societies we never suspected existed because forests hid their remains. Underwater mapping has uncovered submerged settlements. Chemical analysis has identified ancient trade networks. As tools for exploration improve, hidden patterns become visible. The limited range of our current capabilities means that many potential sites remain undetected, not because evidence does not exist, but because the methods to find it are still developing. Thinking about Earth through the lens of a paradox doesn't suggest anything extraordinary. It simply highlights how much of the past is inaccessible due to the nature of preservation. If earlier societies existed long before the earliest written records, they would be challenging to detect. They might have lived in regions now underwater. They might have used materials that decay quickly. Their traces might lie beneath meters of sediment. Their landscapes might have been reshaped by glaciers, floods, or tectonic activity. If even recent societies can vanish almost entirely, then earlier ones would be even more likely to disappear. Trying to imagine the disappearance of technology can feel strange at first because modern life surrounds us with objects that seem too solid, too complex, or too widespread to ever vanish completely. Yet when we examine how quickly the world erases physical traces, the idea becomes easier to understand. Technologies that appear permanent from a human perspective become fragile when placed against the scale of geological time, or even the much shorter cycles of weather, climate, and environment. A device built today may last for years or decades when maintained, but once maintenance stops, the decline begins fast. It doesn't require a dramatic collapse or sudden catastrophe. Ordinary processes of decay are enough. This observation becomes especially important when considering what earlier societies might have developed, and why so little of that development would remain visible in the present. To understand this better, it helps to start with a question about the lifespan of modern objects. Imagine a building filled with electronics, metal tools, plastic components, and detailed machinery. Now remove the people who maintain it. Within a year, moisture begins to seep into any structure that isn't sealed perfectly. Metal parts begin to corrode. Dust accumulates. Temperature changes stress components. Batteries leak. Rubber seals degrade. Over a few years, plastic becomes brittle under sunlight or warps under heat. Wires oxidize, screens fail. Without routine care, even complex devices become inoperable. If we extend this timescale to a few decades, the process becomes more striking. Roofs develop leaks that spread water through wooden frames. Mold grows, floors buckle, windows crack under repeated temperature stress. Animals move into the structure. Insects accelerate decay. Electrical systems break down. After several decades of exposure, mechanics fail and materials weaken. And this description applies to relatively new technologies built with modern refined materials designed for longevity. Take the timescale further. After a century of neglect, many modern buildings collapse, metal rusts through, concrete cracks, crumbles and spalls, plastics degrade into fragments, then into particles too small to hold recognizable shapes. Anything left outdoors decays more quickly. Forest vegetation spreads through the collapsed remains, breaking apart what's left. Rivers shift and erode the ground beneath structures. Wind carries sand that abrades surfaces. Entire sections of a settlement may break apart and scatter. Now, imagine the span of 500 to 1,000 years. What remains is not a city or a technological landscape, but fragments embedded in soil layers. Even durable objects such as metal beams or stone foundations lose their recognizable structure. Iron turns to rust and dissolves. Copper corrodes into salts. Aluminum oxidizes. Plastics degrade into chemical residues. Glass breaks under pressure and temperature variations, eventually becoming unidentifiable without laboratory analysis. If someone attempts to reconstruct such a site after 1,000 years, they might find only a few inorganic fragments, and perhaps some unusual chemical signatures, but nothing that immediately tells the story of a complex society. Extending the timescale further to 10,000 years reveals an even more dramatic transformation. Most modern objects do not survive this long without significant protection. Water infiltrates deep levels of soil. Chemical processes in the ground alter materials. Earthquakes shift layers. Floods wash away remains. Vegetation cycles reshape the environment. Entire ecosystems rise and fall. If any part of a city survives in a recognizable form, it would likely be something large and made from stone. Even then, erosion and weathering reduce details. For example, ancient stone monuments built 5,000 years ago already show heavy erosion today. Imagining 10,000 years of erosion gives a sense of how little survives. If this is the fate of advanced materials built in the recent past, it becomes clearer why earlier technologies, especially those made from organic or semi-durable materials, could vanish without leaving clear traces. A society that used wood, bone, fibre, clay, or other natural materials could build sophisticated tools without leaving behind more than subtle signs. These signs might include soil disturbances, specific patterns of wear, or small fragments of mineralised material. Without context, those fragments are difficult to interpret and may not be recognised as technological. There is another factor that influences how technology disappears: the dependency on local resources and environmental conditions. A group living in a region rich in bamboo or hardwoods might create tools that are strong, flexible, and effective for daily tasks. But these tools would not survive long once abandoned. Similarly, a society that developed techniques for working with natural resins, fibres, or organic adhesives could create complex functional items that leave no trace once exposed to moisture and microbes. Even when technology involves stone, the evidence may not always be obvious. A polished stone tool can resemble a naturally shaped rock after centuries of abrasion. Stone structures collapse and scatter into unrecognisable piles. If the stone used was soft or easily weathered, it may break down entirely. Archaeologists often identify stone tools by looking for specific patterns of flaking, but these patterns do not survive well under intense erosion. If a tool lay in the open for long periods, the surface would weather until the flake scars softened or disappeared. When metal becomes part of a society's technology, the potential for durable traces increases, but only under the right conditions. Copper, bronze, iron, and other metals all corrode. Without consistent maintenance, corrosion accelerates. Over thousands of years, most metal objects erode completely, unless buried in environments that slow the process. Dry deserts, extremely cold regions, or anaerobic sediments in waterlogged areas can preserve metal for longer periods, but these environments are rare, and if the metal used was recycled repeatedly, the number of discarded objects would be small. It is also important to recognise how quickly technology can be lost within a society. If knowledge is passed orally and not written down, it is vulnerable to disruption. A single generation of population decline, migration, or environmental stress can sever the chain of transmission. Once the knowledge behind a tool or technique is lost, the artifact itself becomes a relic without context. If the relic eventually decays, the knowledge vanishes completely. Without durable writing systems, the survival of advanced ideas is dependent on continuous teaching. There are well-documented examples of technological loss in relatively recent history. Some societies once possessed knowledge of long-distance navigation using stars, currents, and wind patterns that later generations lost due to cultural changes. Others developed techniques for creating pottery styles or metal alloys that were abandoned or forgotten. In several regions, agricultural methods that worked for centuries were replaced by different practices, leaving the earlier methods unrecorded. These examples show that even when technology is advanced in some respects, it does not automatically persist. When thinking about civilizations that might have existed long before recorded history, this pattern becomes even more significant. A group could develop specialized tools for their environment that leave minimal traces today. They could create symbolic art on perishable surfaces. They could build structures from wood or earth. They could grind pigments from natural minerals without leaving behind carved stones. They could weave baskets, create shelters, and construct boats entirely from organic materials. If such a society thrived during a period when climate conditions promoted rapid decay, their entire technological base could disappear over time. As we consider more extreme scenarios involving earlier human species or long-forgotten populations, it becomes clear how survival of evidence depends almost entirely on preservation conditions. A village built in a dry cave may preserve artifacts for tens of thousands of years. A village built in a forest may leave nothing after a few thousand. A settlement along a shifting river may be buried under sediment and protected, or eroded away entirely. A coastal community may be submerged by rising sea levels and preserved under layers of silt, or destroyed by waves and currents. In addition to environmental processes, the structure of a society influences how visible it becomes in the archaeological record. If populations were small and mobile, they would leave fewer traces. If they created only temporary structures, evidence would be minimal. If they relied heavily on seasonal resources, their settlements may not have been occupied long enough to leave substantial layers. If they recycled their materials, there would be fewer discarded objects for future excavation. Even if a society did develop tools that we would consider advanced, they might not be advanced in the ways modern humans expect. They might have focused on biological knowledge, navigation techniques, ecological strategies, or social systems that do not leave behind durable artifacts. In that case, the sophistication of their world would be invisible to us today. Another factor worth examining is the possibility that earlier societies might not have spread globally. If a group developed a stable but localized society, they could thrive in one region for thousands of years without expanding beyond it. Their remains might be confined to a relatively small area. If that area later underwent geological change, such as uplift, subsidence, volcanic activity, or coastal flooding, the evidence could be buried or destroyed. Without expansion, there would be fewer chances for later generations to encounter remnants of their existence. From a practical standpoint, this raises a question similar to the original Fermi paradox. If earlier advanced societies existed somewhere on Earth, why aren't their traces obvious? The simplest answer echoes the cosmic version of the paradox. Because we have not looked in the right places, and because the traces may no longer be recognizably artificial. The absence of obvious evidence does not necessarily confirm that nothing existed. It may reflect the limits of detection, the nature of preservation, and the ways in which technology interacts with the environment over long periods. Chemical signatures offer a potential path to detecting vanished technology, but even these signatures are subtle. Industrial activity leaves behind certain patterns of metal concentrations or unusual chemical residues. However, natural geological processes can produce similar signatures. Volcanic activity, hydrothermal vents, and mineral-rich groundwaters can create deposits that resemble those associated with human industry. Distinguishing ancient industrial activity from natural processes becomes difficult without contextual clues, and if technology was based on biological materials or low-impact practices, chemical evidence might not exist at all. This line of thought suggests that civilizations capable of understanding their environment deeply could minimize their ecological footprint. If earlier societies learned to live sustainably, or to rely on natural cycles without intensive resource extraction, their physical impact might be small. A society that used local materials efficiently could thrive without creating waste patterns that stand out in the geological record. In such a case, the more advanced their knowledge, the less they might have altered their surroundings in detectable ways. This idea is not speculative in the modern world. Some cultures have lived sustainably for thousands of years with minimal environmental disruption. Their technologies are sophisticated in their own context but leave behind few long-term traces. A group that mastered ecological stewardship would not necessarily leave behind massive quarries, slag piles, or large industrial zones. Their legacy would be encoded in knowledge, not waste. Knowledge, however, disappears quickly without written records or robust cultural continuity. Thinking through these possibilities reinforces a central idea. Technology does not guarantee visibility. Its survival depends on materials, environment, continuity, and chance. Even technologies that seem advanced to modern eyes are vulnerable to disappearance when left unmaintained. And if earlier societies developed approaches that differ from ours, their technological signature might not resemble anything we expect to find. While considering these possibilities, the question itself becomes less about expecting clear evidence, and more about understanding why evidence might be missing. Earth's surface is not an archive that preserves everything evenly. it erases far more than it saves. Trying to understand what actually survives across long stretches of time requires shifting perspective from the objects we value today toward the limited categories of material that can endure environmental change. The everyday things around us are not designed with geological durability in mind. Furniture, clothing, electronics, paper products, and architectural materials all fall apart much faster than people expect when they stop being maintained. Yet something in us wants to assume that at least a fraction of our physical world will persist. That assumption feels natural because we see old buildings, ancient tools, or fragments of pottery and imagine their survival as inevitable. But when you examine the circumstances behind those surviving pieces, a different picture emerges. Most objects do not endure. Only very specific materials, under very specific conditions, remain recognizable. Understanding this selective survival sheds light on why so much of the past, especially anything older than a few thousand years, appears invisible. Looking first at the materials that endure most consistently, stone offers the most obvious example. Hard, dense rocks such as quartzite, basalt, or certain types of flint preserve flake scars and edges for long periods, even when exposed to weathering. That is one reason stone tools dominate the early archaeological record. But even stone has limits. Softer rocks weather quickly. Sandstone breaks down under water flow. Limestone dissolves when exposed to acidic conditions. Granite cracks under repeated freeze-thaw cycles. A stone tool lying on the surface will lose its features far faster than one buried in protective sediment. And once a tool's flake patterns erode, it becomes difficult to distinguish from a naturally broken rock. That transformation makes it easy for early technological traces to blend back into the broader geological landscape. Beyond stone, other materials that survive well tend to be mineral-based and located in environments with minimal disturbance. Fired clay can endure for thousands of years, but only when it remains dry or covered by stable soil layers. If exposed to moisture, it can weaken and flake. If exposed to heat, it can crack. If trampled repeatedly by animals or humans, it can break into pieces small enough to be overlooked. Even pottery, which many people imagine as robust, often survives only in fragments. Those fragments reveal useful information, but they represent only a fraction of the original objects. And pottery appears relatively late in human history. Earlier societies that relied on containers made from wood, woven fibres, animal skins or gourds left behind almost nothing from those categories. Metal provides another example of selective survival, but its endurance varies based on composition and environment. Gold resists corrosion well, but it's soft and was rarely used in early utilitarian tools. Copper and bronze corrode over time and can eventually dissolve into mineral deposits. Iron rusts quickly unless buried in dry conditions. Steel depends heavily on protective coatings or regular maintenance. Without such protection, it breaks down through oxidation. Even in archaeological contexts where metal survives, it often does so as heavily corroded lumps that require analysis to identify. These pieces may not convey much about their original form beyond general outlines. If a society used metal sparsely or recycled it consistently, the number of discarded items would be low. Over long periods, even those few items might degrade into forms that look like natural mineral concentrations. Organic materials show the steepest decline in survivability. Wood decays quickly in humid environments, and even in drier climates it can be eaten by insects or damaged by fungi. Fibres from plants or animals weaken under moisture and sunlight. Leather shrinks, cracks, and decomposes unless kept under exceptional conditions. Textiles rot rapidly unless stored in darkness and dryness. Bone survives better than some organic materials, but can become brittle, dissolve in acidic soil, or break apart through pressure and temperature fluctuations. Many early technologies depended heavily on organic components. Bindings for tools, glues made from animal products, ropes, baskets, mats, shelters, boats, clothing and containers. The absence of these items in the archaeological record does not reflect their rarity in ancient societies. It reflects their vulnerability to environmental processes. Beyond material decay, geological processes play a crucial role in determining what survives. Over long periods, sedimentation can bury artifacts deeply, protecting them from surface weathering. But sedimentation can also crush or distort delicate materials. Volcanic ash can preserve organic structures by encasing them, but it can also obliterate entire regions if the ash mix is heavy or hot. Waterlogged environments can preserve wood and fibre exceptionally well by creating oxygen-poor conditions, but these environments are rare and typically localized. Frozen environments preserve organic materials through temperature stability, but as climate changes, thawing can destroy previously well-preserved layers. Dry caves preserve bones, plant fibres, and tools with remarkable longevity. But such caves represent only a small fraction of potential habitation sites. Erosion removes far more than sedimentation protects. Water can wash away entire layers of soil, exposing artifacts briefly before scattering them or breaking them apart. Wind shifts sand and dust, wearing down surfaces or burying sites unpredictably. Earthquakes disrupt layers, mixing older and younger materials. Landslides move objects downslope or bury them under meters of debris. Over tens of thousands of years, these processes eliminate the majority of physical signs left by human presence. When researchers find older sites, it is usually because of unusual preservation circumstances. Caves offer one, peat bogs offer another. Deep lake sediments can preserve plant remains, pollen, or even wooden structures. Tar pits preserve bones. Arid deserts sometimes protect textiles or wood, but these environments are the exceptions. Most of Earth's surface does not provide these protective conditions, and even when such preservation occurs, it often represents only a narrow window into the broader picture of human activity. This selective survival creates a bias in the archaeological record. We know about societies that built durable structures or created objects from long-lasting materials. We know less about societies that relied on perishable materials or structured their lives around habits and practices that do not leave behind recognizable artifacts. We know more about groups that lived in caves than those who lived in open-air settlements. We know more about groups in dry climates than in humid ones. We know more about groups that consume materials in ways that left accumulations of waste than those who managed resources efficiently and produced little discard. Another category of survival involves indirect traces. Pollen preserved in sediments reveals what plants grew in the area. Charcoal reveals fire use, even when the tools that made the fire are gone. Soil chemistry can indicate long-term habitation, livestock presence, or food processing. Microfossils reveal diets or environmental conditions. These types of evidence help fill gaps left by the disappearance of physical artifacts, yet they require careful study and specialized techniques. Without intentional analysis, indirect evidence remains invisible, and because soil conditions vary widely, many traces dissolve without leaving anything measurable. When thinking about the deep past, organic and chemical signatures may be the only surviving evidence of entire lifeways. For example, if a group used a particular plant for food or tools, the pollen from that plant might appear in layers associated with their settlement. If they used fire regularly, charcoal fragments might accumulate in certain layers. If they processed specific materials, microscopic residues might cling to soil particles. These traces reveal patterns of activity even if no tools or structures survive. But detecting these traces requires targeted excavation. In many regions, these layers lie buried under more recent deposits or under landscapes reshaped by water or wind. What survives also depends on what was originally present. A society that created large earthworks, mounds, or terraced landscapes leaves behind more visible traces because altering terrain creates durable patterns. These modifications can persist even when structures made from organic materials disappear. Subtle changes in soil layers, differences in compaction, or variations in plant growth reveal these earlier modifications. But if a society did not modify the landscape on a large scale, their presence may be nearly invisible without deep excavation. One of the most enduring questions in archaeology involves how much of the ancient world we can reasonably expect to find. Even when researchers work with sites only a few thousand years old, the survival of evidence varies greatly. Extending this timeline to tens or hundreds of thousands of years amplifies the challenge. If a society thrived during a warm period and used materials adapted to its environment, the likelihood of those materials surviving long enough to be discovered becomes extremely low. If that society experienced a decline due to climate change or migration, the final layer of their presence could be scattered quickly. The oldest surviving tools and structures we know of endure because they happen to be in places that offered rare protection. Without caves, sediments, or unique environmental conditions, they would not be visible today. This means the archaeological record is not a full archive of human activity, but a selective sample shaped by chance. For every site preserved in exceptional conditions, countless others have been erased. Understanding this helps reframe the question about what civilizations or societies could have existed before the earliest known examples. It is not a question of proving that such societies existed, but of recognizing how easily the evidence for them could disappear. The idea of a vanished world does not require assuming advanced technology or monumental architecture. It requires only the ordinary pattern of human life carried out in environments that do not preserve materials well. Thinking through what survives also clarifies how we interpret ambiguity. If researchers find a stone tool in an older layer, they may debate whether it resulted from deliberate shaping or natural forces. If they find soil with unusual composition, they may consider whether it resulted from human activity or from environmental processes. Without clear context, these interpretations remain cautious. This caution protects scientific rigour, but it also means that subtle traces of earlier societies might remain ambiguous indefinitely. As new technologies for detection emerge, the range of surviving evidence expands. Remote sensing can identify buried structures. Chemical analysis can reveal residues invisible to the naked eye. Micro-excavation can uncover small details missed by earlier methods. But even with improved tools, the basic reality of selective preservation remains unchanged. The vast majority of physical objects, especially those made from organic materials, do not survive long enough to be detected without exceptional circumstances. Reaching this point in the journey invites a quieter kind of reflection, the sort that settles in only after moving slowly through a long landscape of ideas. We've walked through shifting coastlines, vanished settlements, buried artifacts, reconstructed memories, and geological processes that have erased far more than they preserved. Now the pace changes slightly. Instead of examining another pattern or presenting another set of conditions, it becomes useful simply to take a steady breath and look at everything from a wider vantage, the way you might pause on a hill overlooking a valley after travelling through it for hours. That shift doesn't bring final answers. It just offers a moment to see how the pieces fit together across the long distances we've covered. Thinking about earlier civilizations or societies is not an attempt to create mystery where none exists. It comes from recognizing how little of the past survives and how many layers of Earth's surface have turned over since the earliest humans appeared. If someone were to examine the world tens of thousands of years from now, the physical imprint of the present era might look much thinner than we imagine. Our buildings would mostly have collapsed. Our objects would be fragments mixed into soil. Our coastlines would look different. Rivers would cut new paths. Forests would grow over abandoned regions while deserts expanded in others. Whatever remained would depend entirely on chance and on the stability of the specific environments that received those remnants. If this is true for the modern era with all its durable materials, it becomes easier to understand how previous societies might have risen, changed, adapted, and disappeared without leaving records we can easily recognize. The earliest human groups lived in conditions far less favorable for preservation. Their shelters were built from materials that decay quickly. Their tools, if made from stone, may resemble naturally broken rocks after long enough exposure. If built from plant fibres or bone, they would not endure unless protected under exceptional conditions. A single flood, wildfire, or period of heavy rainfall would remove many traces. Add in the slow, consistent processes of erosion, sedimentation, and biological activity, and it becomes clear how quickly the physical signs of ordinary life vanish. Across every region of the world, people have tried to understand their place within these cycles. They created stories about origins, migrations, ancestors, and landscapes. Some stories preserved memories of real events. Others expressed observations about environmental shifts. Still others carried lessons or warnings. These stories outlasted the objects their ancestors made because memory adapts, reshapes, and travels more easily than wood or fibre or clay. Considering the past through this combination of material evidence, environmental processes, and preserved memory gives a more rounded picture of what may have existed long before the earliest written records. If we imagine ourselves standing at the edge of deep time and looking backward, the visible parts appear small compared to the vast stretches hidden from view. We see the artifacts that happened to survive due to fortunate environmental circumstances. We see the ruins that resisted erosion long enough to be noticed. We see the tools made from the hardest stones. But we do not see the thousands of settlements built from organic materials. We do not see the communities that lived along coastlines since submerged. We do not see the shelters that collapsed and decomposed entirely. We do not see the knowledge that existed only in memory and disappeared when its last bearers were gone. This isn't a gap created by a lack of research or imagination. It is built into the nature of the world. Every landscape humans have walked across has shifted multiple times. Rivers rearranged their courses, lakes expanded and contracted, sea levels rose and fell, forests grew where grasslands once stretched, and grasslands replaced forests in turn. These changes happened repeatedly over hundreds of thousands of years. A settlement that thrived in one climate may have had to relocate when the climate shifted. Over many generations, these relocations would leave behind layers of activity spread thinly across large areas. Without dense populations or permanent structures, the archaeological visibility of such societies remains low. Understanding this gap helps explain why the earliest known examples of complex societies appear suddenly in the record. It's not that humans lacked the capacity for organisation or knowledge before that point. It's that earlier examples were built in conditions that did not preserve their traces. Once people began using materials that resisted decay or building structures in environments with stable protective layers, the record became clearer. Before that point, the gradual accumulation of culture, skill and tradition moved through generations without leaving behind the durable evidence needed for archaeologists to reconstruct the details. And yet, even with all these limitations, the physical remnants that do survive offer remarkable insight. A few stone flakes can reveal patterns of toolmaking from hundreds of thousands of years ago. A small fragment of pigment on a rock can show that early humans cared about expression, symbolism, or communication. Burned bones can reveal the use of fire. Isotopic signatures in soil can show where people lived and how long they stayed in one place. These fragments do not tell the full story, but they demonstrate how much human activity can be inferred from even the smallest surviving traces. If we think about how much is missing, it becomes tempting to imagine entire civilizations that developed advanced technologies we have yet to recognize. But the idea of advanced depends heavily on assumptions shaped by modern society. A group could be advanced in its navigational knowledge, its ecological understanding, or its social structures without creating the types of objects that last for thousands of years. A society might have refined ways of managing resources, constructing shelters, or organising daily life that left minimal physical footprint. Knowledge does not always manifest in durable artifacts. It can reside in practices, behaviours, and solutions adapted to specific environments. This invites a more open view of the past. one that does not assume a straight line of progress from simple to complex. Instead, it recognizes that human history is marked by periods of growth, stability, change, and loss. Some knowledge persists, some disappears, some reappears in new forms, and some leaves only faint marks that researchers interpret cautiously. This pattern is consistent across cultures we know well. There is no reason to assume it was different in earlier eras for which evidence is scarce. When thinking about forgotten worlds, it becomes useful to consider how different the Earth's surface looked during older periods. Entire continents have shifted position. Mountain ranges have risen and eroded. Volcanic fields have appeared and vanished. If a society thrived in such a landscape, its remnants might now lie under layers of solid rock, buried deep in sediments, or submerged beneath oceans. Even if archaeologists had perfect tools, reaching those layers would be nearly impossible. Most of what happened on those landscapes would be inaccessible simply because the Earth has changed too much since then. It's not just geological processes that obscure the past. Biological processes contribute as well. Plants grow over old sites and break apart structures with their roots. Animals dig burrows that disturb layers. Microorganisms break down organic matter. Fires sweep across regions and remove surface traces. Over long enough periods, these biological influences blend human activity back into the environment, until nothing clearly distinguishes one from the other. Despite all these erasing forces, some traces remain, not necessarily of civilizations, but of the continuity of life. A handful of footprints preserved in hardened sediment, a piece of bone showing tool marks, a patch of soil altered by repeated habitation. These subtle signs remind us that humans and earlier human species lived through countless environments, formed countless communities, and confronted countless challenges. Their stories may be largely invisible now, but the existence of these small clues suggests that much more once took place than the surviving artifacts reveal. Considering the possibility of earlier civilizations doesn't require speculation beyond what is already known about geology, climate, and human behaviour. It only requires acknowledging that the absence of evidence does not automatically indicate the absence of activity. The visible record is shaped by preservation, not by the totality of events. This understanding allows us to appreciate how the known world fits into a larger context. A context shaped not just by what survived, but by everything that didn't. For listeners who have travelled through this entire exploration, the idea of standing at the edge of human knowledge might feel different than it did at the start. Instead of wondering solely about what evidence exists, the question shifts toward how much of the past lies beyond reach, simply because the Earth has always been in motion. The puzzle becomes less about discovering forgotten civilizations, and more about understanding the natural limits of memory, material, geological, and cultural alike. This leads naturally into the quiet recognition that the present moment is also part of a future layer, one that will be reshaped, eroded, buried, or transformed by forces beyond our control. Everything familiar today will eventually become part of the same long process that turned earlier worlds into fragments. The cities, tools, stories, and ideas we consider enduring will be filtered by time. Some will vanish, some will remain, some will merge into broader patterns that future generations interpret cautiously. Realizing this does not diminish the significance of what exists now. Instead, it broadens the sense of connection across different eras. The people who lived before us, whether we have detailed records of them or only scattered clues, faced the same Earth we inhabit. They adapted to its cycles, made choices based on their environments, and left traces shaped by chance. Their knowledge may be gone, but their presence shaped the long continuum that leads to the present. Holding that perspective brings a kind of steady calm. It highlights the continuity between past and present, without demanding final answers. And it leaves the mind open to the idea that the story of humanity is larger than the visible pieces suggest. As this thought settles, it makes room for everything still waiting beyond the edges of what we can see. New discoveries, new questions, and the quiet possibility that the Earth holds far more stories beneath its surface than we have yet imagined, carrying the path onward without closing it.